everybody! Hi, welcome, welcome. Why don't you give yourselves a big round of applause for being here at Devcon? The biggest Devcon event ever, and I think the most diverse as well. My name is Ross. I'm going to be your MC for the main stage for the duration of the talks this afternoon and evening. Great to see you guys. More people coming in, so please, come and find your seats. I see some seats in the front, on the left and the right. Come closer. The closer you are to the stage, you get to see our speaker up close and personal, and my hair in high definition as well. I see many of you wearing your little frog hats. I saw it. It's so cute. I just wish there was a hat that I could wear. Sadly, I cannot, so I had to give it to a friend. But nevertheless, please feel free to wear your swags, be proud, and be excited to be here at Devcon. Now, our topic for today is very interesting. It is a keynote session executed inside of or on top of cryptographic objects. How many of you did not understand that? All right, good, because this is a beginner level session, so this is the perfect place to be to learn more about programmable cryptography. In essence, what we want to do with Ethereum and programmable cryptography is to create the internet for the next 50 years. How can we bring the power of the entire global internet on-chain? Well, programmable cryptography might just be the solution. Are you guys excited to find out more? All right, well, before I welcome the speaker, I've got a very important reminder. Part of having a great session, part of having an amazing session is audience engagement through the Q&A. So later throughout the session, there's going to be a QR code on the screen. I'm going to ask you to please scan it. It will open up your Devcon Passport app. Please scroll to the bottom of the app and you'll see a variety of buttons there. Focus, if you can, please, on the Q&A button. And you can already start submitting your questions. All right, so scan it later, submit your questions so we can have a great time of Q&A. Ladies and gentlemen, without further ado, let's welcome our speaker for this morning. Now, he's the co-founder of 0x Park as well as the creator of the Dark Forest game. Please put your hands together and let's warmly welcome to the stage, Gupsheep! Take it away.
Awesome. It's great to see everyone at Devcon. Thank you all for coming. Today, I'm going to be talking about programmable cryptography and Ethereum. As a quick introduction, I'm Gupsheep. I'm one of the co-founders of 0x Park. We're an organization that emerged out of the Ethereum ecosystem about 3 years ago. And since we first coined the term programmable cryptography in 2022, we've been working to accelerate the development of the field from a technical, ecosystem, and conceptual perspective. Our goal is to take programmable cryptography from research to production and to harness its powers for a new digital universe. A lot of this talk will center around the following question. How do we compute together? Specifically, how do we, as in a group of multiple people, perform a computation or execute a program together? Now, to give some context on this question, I want to take us back about 30 or 40 years to the earliest days of the internet. In the beginning, the internet was a peer-to-peer network for essentially transmitting bits between equal peers. This means that you could do things like send a document to another IP address using protocols like FTP or SMTP. At this point, there was not yet any notion of web servers as we traditionally think about them today, or the client-server model. Rather, the internet, instead of being an answer to the question of how do we compute together, was more of a peer-to-peer network for communicating together. But computing is something much more than that. And pretty early on, people started to realize that it's useful to be able to do more than just send data back and forth. It would be useful to be able to run programs on this data that's being passed around on the internet. But with the existing setup of the internet in the early days, there was a problem. In the days of the early internet, the ability to compute was limited to individual machines running programs over their own data. So you could only run a program over data that lives physically on your own device. That makes sense. So most apps looked like single-player programs. Imagine games like Solitaire, a single-player game, or something like Flappy Bird, or tools like spreadsheets, or word processors, or photo editing tools, or a calculator that just runs locally on your own device. But of course, we wanted to do more. We wanted to compute together and to have services like marketplaces or ride-sharing apps or social networks or massively multiplayer games or global payment systems or dating apps or all sorts of things. And so we came up with a way of sort of simulating this idea of computing together, while in reality we were actually still sticking to the single-player compute model. And that first solution, the strategy for the last 30 years, has been to pick one very important node, like Dave over here in the middle, and to promote Dave such that we all give Dave all of our data. And now Dave can basically run something like the Facebook backend as if it was a single-player application running just on Dave's machine. So this has been the status quo for many decades. And from this example, we can sort of see why servers came to exist in the first place. Web servers do several things that individuals and pure peer-to-peer networks, like the early internet, can't do alone. Web servers allow us to coordinate on and perform computations over multiple people's state. That state might be private to some particular subset. It might be public. It allows us to decide which state is canonical. And web servers also provide strong uptime and liveness guarantees that don't necessarily exist in a peer-to-peer network. So, this has taken us pretty far, but one question is can we do better, right? There's been a lot of problems that have arisen as a result of this being the fundamental architecture. And in fact, these problems are a big part of why many of us today are in this room. You can feel free to choose the problems you care about. There's all sorts of things. And when we return back to the question then of how do we compute together, we have to ask, is there a better way that we could go about this, right? And one of the really interesting discoveries of the last decade is that blockchains, crypto economics, and Ethereum have given us new answers to this question for the first time in decades. Right? So now Ethereum allows us to run a single computer collectively in a way that's sort of very different than the traditional model where we promote that one single node, Dave, to be a very important node that we give all of our data to. So Ethereum has given us extraordinary things, many of which we saw this morning. Because we have the ability to have decentralized consensus over global state, we have neutral and autonomous marketplaces, financial derivatives, prediction markets, we have payment systems that no single authority controls, we have permissionless identity registries spinning up, we have interoperable and composable games. But we also can't do everything that we want yet. In fact, nearly everything that I showed on the previous slide is still beyond the capabilities of Ethereum alone. And not just as a result of performance, but as a result of fundamental architecture and capability limitations. So, enter programmable cryptography. Programmable cryptography is a technology that can give us many more answers to the question of how do we compute together. And it can give us these answers both independently and in combination with Ethereum. So what is programmable cryptography? For those of you who aren't familiar with the term, programmable cryptography refers to a second generation of cryptographic primitives that have started to emerge and become viable in the past 2 to 5 years. These include technologies like general-purpose zero-knowledge proofs, multi-party computation, fully homomorphic encryption, witness encryption, functional encryption, obfuscation, and more. These advanced technologies are the ones in bold here, and one of the key features is that they share sort of an underlying theoretical common backbone, and that they generalize familiar Generation 1 cryptographic technologies like signatures and encryption. So you can sort of see a lot of these technologies in the shape of a tech tree, where protocols higher up on the stack generalize things lower down on the stack. So programmable cryptography moves us from a world where we have proofs for specific functions, in the world of Generation 1 or special purpose cryptography, to being able to perform proofs of any function or any computation. We can go from being able to verify specific claims to being able to verify any claim. And in general, we move from special purpose protocols to general purpose cryptography compilers. To make a hardware analogy, this is sort of like the transition from special purpose hardware, like an alarm clock or a 4-function calculator, to something like a CPU, which is generally programmable. What's changed in the last couple of years to make this an area of technology to focus on now? Well, first off, there's been significant technological advancements over the past 2 to 5 years that have made programmable cryptography more approachable. On the theoretical level, every item on that previous tech tree that we just showed up here is sound and has a theoretical construction that is believed to be secure. In fact, candidate schemes, even for the most expensive protocols like obfuscation, may even be practical. On the engineering level, some of the first branches of programmable cryptography, like general-purpose zero-knowledge proofs, have become practical for developers today to start using, even developers who aren't cryptography specialists. In addition to the technology advancements, there have also been significant conceptual advances over the last 1 to 2 years. We've recognized programmable cryptography for the first time as a unified set of capabilities with a common foundation, and we've started to understand how we can leverage the power of programmable cryptography to build powerful systems that were not possible before, rather than simply seeing things like ZK snarks as a one-off way to perform a certain kind of hack to be able to introduce a specific kind of privacy feature onto a specific kind of blockchain architecture. We sort of understand how to use the general programmability of these tools. Okay, so let's return to our question of how do we compute together. I want to think about this phrase multi-party programming, the act of multiple people coming together and trying to perform some computation together. Again, this has been the strategy for the last 30 years, but abstractly from first principles, if you think about this idea of multiple people coming together to run a program, you might abstractly want something that looks like this. So you have some sort of network, you have some sort of participants in the network that want to do some action, and they gather all their respective data that's relevant to the computation, and they produce the result of the computation, and they want to be able to do so with privacy, integrity, interoperability guarantees, and for this to be practically feasible. So let's zoom in and look at the anatomy of such a program. The general pattern here is slightly more complex than this diagram that we're zooming in on, but not by much. Essentially, in one of these multi-party programs, there might be 3 kinds of data that we would be interested in running our program on. There's some sort of global public data that everybody knows, and then there's data that might belong to or live on the machines of specific participants in the computation, and then there might also be data that only the program knows. And we'd like to be able to run some kind of program over all 3 types of data to produce an output. Now, Ethereum gets us part of the way there. Ethereum allows us to collectively run a world computer that takes in some global public state and perform a verifiable computation together on that. But like other peer-to-peer systems and blockchains, historically, full multi-party programming has not been possible with this model, being able to do this with all of those different kinds of state. So everything I've been saying so far has been a little bit abstract, and I want to dig into a specific example. Lately, there's been a lot of interest in decentralized social media in particular. We've seen protocols and applications like Farcaster, Blue Sky, Nostr, and Mastodon start to emerge, and communities to get built on top of these. One thing that's really interesting about this trend to me, and one pattern that I've observed, is that people tend to frame the problem of decentralized social media or building a decentralized social app in terms of building a decentralized Twitter. We always very specifically use Twitter. My question is, why do we always talk about decentralized Twitter? Why don't people talk about one of the other social medias out there like building decentralized Facebook? There could be cultural reasons behind this. Maybe people interested in decentralization tend to have congregated on Twitter. But I think that there's also a deeper technical reason behind this as well. And the reason for that is that the state topology of Facebook is much more complicated than the simplified model of Twitter. In Twitter, everyone can see everything, and everyone broadcasts every post to everybody else. So now you sort of need to reduce this down to some sort of decentralized messaging protocol, in essence. So the state topology of Twitter might look something like this. It's a very homogeneous, simple thing to reason about. Whereas the state topology of Facebook is much more complex. Right? You might have things like friends of friends can see my timeline. We might have private groups where things happen. You might have personalized recommendations based off of how your history intersects with other people's history, or APIs that behave differently depending on the combination of multiple people's settings. This person's a third-degree connection, and that influences my recommendation somehow, et cetera, et cetera. So the state topology of Facebook looks much more complicated. And in the general case, emulating those kinds of more complex topologies or multi-party programs is impossible to achieve empirically with only generation 1 cryptography and even some forms of consensus. Another issue that really shines a light on the fundamental limitations of our existing tool stacks is some applications have what we might think of as private global state. So this is state that's part of the application that is computed on and is necessary for the operation of the system, but which no user of the system knows or owns. So you can imagine having a bit in this system that doesn't actually physically live on anybody's computer, but is a necessary input to some of the computations that are running. You know, in a social media, you might have a list of all the user IDs that have been reported at least 3 times for bad behavior or something, like the naughty list. And one of the issues here is, well, if you try to emulate this in a decentralized fashion and nobody has that array stored locally, but you still want to be able to perform computations on that, well, that seems paradoxical. Another pretty clear example of this is in some kinds of games. You might have strategy games where there's multiple players. Each player can see some part of the world or the global map. But there's also stuff going on in the fog of war that nobody has access to. Maybe NPCs are moving around or some processes are running. And so these are things that only the server knows. But because they can eventually interact with a given player's state, you might need to ensure that somehow this state is still being updated and operated on in a consistent way, despite the fact that it doesn't actually live anywhere. So in short, you know, why is it hard to build something like a decentralized Facebook? Well, first off, if you have a transparent data layer, individuals can't really have their own state. A lot of decentralized systems need their state to be public so it can be verified. And the system itself might also have some notion of global private state. And it seems almost paradoxical to imagine a system made up of a bunch of users that's performing a computation on a variable that no single person owns or can read or has. So enter programmable cryptography. Programmable cryptography has the ability to potentially start to emulate some of these capabilities. If we break down what we would need from our multi-party programming model, we can write down a couple of things that we would need to have happen in order to be able to emulate these capabilities in their full generality. We would need verifiable computation because, you know, rather than one trusted actor running the program, we might have this world where programs can be run across multiple different computers or by someone who you don't even know and you don't even have to care about who's running the computation. We'll need execution on private state because if that program is physically running somewhere, it has to be running on state that might exist in some other part of the network that the person who's executing the code doesn't actually have access to the internal state of. We want data interoperability. We want the ability for, you know, the outputs of certain programs or certain services to be usable in other ones. We want consensus so that everybody can agree on the canonical program state or the canonical state of a given multiplayer service. And we want non-interactivity to be able to scale to billions of participants. A lot of this mental model is spiritually very similar to what Vitalik discussed in one of his recent blog posts with the 3 Egyptian god protocols looking forward to the far future of Ethereum. So let's take a quick look at each of these in succession. Let's look at verifiable computation. So we want to live in a world where we can execute programs over a network. And these programs might be running somewhere untrusted. They might be running in a place that I can't determine in advance, ahead of time. And we somehow want to still know that that program is running correctly. Well, this is the sort of guarantee that general purpose ZKPs like Snarks and Starks give us. And we've seen phenomenal progress in this domain over the past couple of years with the ability to even run virtual machines performantly inside of verifiable ZK Snark protocols. In terms of programming on private state, well, one of the dual problems to the world where we have multiple actors who might be running the program is that if those actors are running the program, they might be running it on state that lives elsewhere in the network. And because of that, they need to be able to execute code on top of state that they don't know or perhaps nobody knows. So this is something that is at least partially solved by technologies like fully homomorphic encryption. And we've started to see the first tool stacks like Phantom Zone or OpenFHE become possible for developers to use. In fact, we have a demonstration of a game running inside of this sort of hallucinated server downstairs. If you check out the Frog Community Hub, there's a game called Frog Zone where there's a backend that holds about 500 bits of game state that's running inside of fully homomorphic encryption that you can play. We want data interoperability. We want for the outputs from one service or computation on this network to be usable elsewhere. This is one of the big problems with the internet today. And for this, we've seen various groups, projects, and companies start to approach the idea of proof-carrying data. The idea that I can take data in that is cryptographically verified, I can perform operations or run programs on it, and I can get an output that is just as verifiable and inherits the interpretability and the verifiability of the inputs to that transformation process. Projects like ZK Email, TLS Notary, ZooPass, and many other ZK ID projects are starting to build up towards a future where data is default interoperable, self-verifying, and self-describing. We want consensus and data availability. This is something that actually no amount of cryptography can give us. But we want to make sure that even if a program is being run somewhere, even if it's being run correctly and with confidentiality, and it's producing some sort of outputs, we want for everybody to be able to retrieve those outputs. It's not enough to just know that something was done correctly. Sometimes there's actual pieces of the state that you need to be able to retrieve. And this is what blockchains give us. This is what the big innovation in crypto economics and consensus over the past decade and a half have been. And finally, we want to be able to do all of these things in a scalable way. Many of our strategies today for carrying out these functions rely on these very interactive protocols where everyone must be online at once. So imagine a world where we're all emulating the execution of a social media backend, whether that's Twitter or Facebook or whatever social media you want. We don't want to have to require that all of a billion people or billions of people are online all the time to do decryptions or various kinds of cryptographic interactions. What we'd like is for only the involved parties in any given interaction to need to be online to participate. And this is what the most advanced branches of the programmable cryptography tech tree, like obfuscation or functional encryption or witness encryption, give us. As of about 3 or 4 years ago, obfuscation and functional encryption are known to actually be sound. So while this is the furthest along in the tech tree that we're working on advancing, we know that it is possible. So to summarize, there's a couple of questions that we can look back on and ask. One is, what can cryptography do that Ethereum alone cannot do? In short, as we've seen, cryptography allows us to build rich applications with complex interoperable state. It allows us to answer questions like, how can domains that use different data schemas, proof systems, or semantics talk to each other? How can applications hold state with complex predicates on who can see it, who can read it, who can write to it, who can operate on it? And how can an application have state that nobody knows? Conversely, we can also ask, what can Ethereum do that no amount of cryptography can do? And while we're just starting to understand the limits and the boundaries of these technologies, in short, we might say that blockchains give us things like consensus, data availability, and ordering. A ZK proof allows you to prove any fact that you want about a hash or a hash preimage or a public key, but how do we decide which hashes and public keys are meaningful? How do we come to consensus on which of these hashes actually reflect something that we care about in the world? How can you prove that something didn't happen? You can't easily do this with cryptography except in very special purpose cases. Or how can you determine which of two cryptographically sound operations happened first? Or that data has been made available, or that participants in a network are live or incentivized to be online. Again, these are things that pure mathematics and pure cryptography alone cannot do, but blockchains in synergy with these things can bring as well.
Those are some great questions, Gubsheep, and I'm sorry to cut you off a little bit, but because of time, is it all right if we can move on to the Q&A section so we can listen to a bit of the questions from the audience?
For sure. Yeah, so to sum it all up, the one challenge that I'll give to everybody is to think about the question, how do we compute together? How can we use these technologies to pull forward a future where multi-party programming actually reflects the natural first principles model? So thank you, everybody, and we'll take some questions now.
Hello. All right, let's hear it for Gubsheep. Straight away, our first question on the board. What is the coolest thing in ZK research right now for fast client-side proving?
Yeah, so I'm extremely interested in some of the projects that have started to really take client-side proving seriously. I think that because of the economic incentives of things like rollups and bridges, we've seen a lot of advances on making ZK proof generation very efficient on big and beefy servers, things like sequencers or block producers or things like that. Because of the increased focus on ZK identity by the space in the last couple of years, we're starting to see the first projects from groups like IDEN3 or PSE experimenting with using new proof systems in order to build fast client-side mobile proving libraries that actually run natively. So I think that there's a lot of low-hanging fruit here, and I think that hopefully one of these teams is able to start pulling out something where someday we might be able to even run a ZK VM on the phone efficiently. I think that would be huge for the space, and lots of research needed.
Definitely lots of areas for experimenting and trying new things. Let's go to the second question, which got the 3 highest votes. Will this enable decentralized LLM inference while preserving the privacy of user prompts? If so, how far away is it? If not, what tech do we still need to enable this?
Yeah, this is a really interesting question. I think a lot of folks are curious about what the intersection between technologies like ZK or verifiability and AI is going to look like in the near future. In general, I have 2 minds about this. I think that trying to plug in our bleeding edge LLMs or bleeding edge machine learning models into programmable cryptography is likely going to be something that takes a lot more time than a lot of the other use cases that we might have around things like identity or proof carrying data, largely because AI is something that will eat up as much compute as you're willing to give it. And if programmable cryptography causes you to incur like a 1,000x overhead, then there's many use cases that it's just really hard to justify. But I am very interested in this idea that perhaps in the future, where a lot of the internet is made up of different autonomous agents or machines or bots, they might be speaking in cryptography to each other. So how bots might make sense of the semantic contents of what each other is saying is they might be speaking in proof-carrying data, sending bits of cryptographically verifiable things. We could imagine these things combating stuff like misinformation or the lack of interoperability between different services. Personally, I'm very interested in that.
Interesting. Let's go on. We got time for maybe 1 or 2 more questions. Why haven't traditional companies invested in this area of research? Why do you think, Gapship?
Yeah, I think that one thing which I think we'll probably also be discussing in the panel following this is that the reality is that the economic incentive over the last 5 years has driven research and development largely towards use cases that involve things like server-side proving, and with a focus on verifiability technology rather than confidentiality technology. In particular, because blockchains have created such a phenomenal financial incentive to actually build out these businesses, a lot of the oxygen in the room gets sucked in that direction. So what we've been trying to do at 0x Park and amongst a couple of our other partners is start to direct attention towards these other further out, potentially more speculative use cases that don't have as strong of an immediate financial incentivization loop. But I think we're going to see this pattern play out more and more as these use cases start to become a reality.
Excellent. That's all the time we have for Q&A. Let's give our speaker another big, big round of applause. Thank you very much, Gapship. All right. Now, I know I saw you guys voting for a few more really fun questions coming up as well. Don't worry, Gapship's going to come back later because we're going to have a panel session on the same topic, right, of programmable cryptography. It's a really big topic, and initially when I read it, it said beginner track because I'm not a tech person, so when I saw beginner track, I was like, okay, I should be able to understand. But no, not really. It is quite complicated, even for me. But for those of you in the audience, if you do understand and you find it exciting, I tell you, this session was really good. It was pin drop silence. Everybody was paying full attention, and our speaker, he was going like a choo-choo train. I think he barely took a breath, speaking non-stop for the past 20 minutes. I think that's wonderful because you guys are here to get as much value, and our speakers are here to give you as much value. Now, I love the questions that were coming in. Remember, you don't just have to post a question, you also can vote for the questions that you think are the most interesting. I'm going to choose the one that get the highest votes, and we're going to see them on the screen as well, all right? Now, some of you are leaving the auditorium. That's fine. If you want to go for another session, feel free. There are lots of sessions, 450 talks, but if you need to leave, please do so quickly and quietly, right? So that we can continue with our panel session on programmable crypto, right? If you need to do it now, if not, sit down and hold your peace, okay? All right, a few more people leaving, so I see a majority of you are staying. Are you guys excited about the future of Ethereum? Yeah, that's what I like to hear, you know? Ethereum really is quite life-changing, and as he said earlier, the real question to be asking is, how can we compute together? How can we compute together? That's just one question. We've got many questions, and our panel is going to be discussing some interesting questions as well. Now, the topic is going to be the same, programmable cryptography, And some of the questions that the panel is going to be asking themselves as well for the audience to reflect on is, why have we not been able to do everything we've wanted with Ethereum? What's in our way, and what kind of tools like programmable cryptography can we apply to change the future? Without further ado, let's kick off our panel and let's invite our speakers onto the stage. Albert Nee, Barry Whitehead, Gupship once more, and Vitalik Buterin. Let's give them a big round of applause as we welcome them onto the stage. Over here, gentlemen. Thank you.
Testing, am I here? Awesome, I'll give everyone another 15 seconds or so to get situated. And as folks are getting situated, I guess I'll just first say, welcome everybody to what I hope will be one of the many highlights of your DevCon experience. My name is Albert, and I'm delighted to be the host, moderator, and perhaps even provocateur of this panel. Joining me, as has been said, is the one and only Gubsheep, Barry Whitehat, and V-Dog. Three very low information names, taking this zero knowledge thing a bit too seriously, if you ask me. Though I guess Whitehat is a positive piece of information. Like, you know how people in the West, they have these family names like Taylor or Carpenter or Smith or Shepherd. Maybe one day in the digital realm, it'll be full of white hats, but I digress. Today we're going to discuss programmable cryptography and Ethereum. This is exciting for a bunch of reasons. One that stands out is that the four of us convened at the last DevCon in Bogota for a panel that we titled What to Know About Zero Knowledge. Now, I know most audience members didn't see that simply because there's so many more people at this DevCon than even the huge number that was at DevCon LATAM. But as those who did see that panel may recall, I started that panel by apologizing. Why? Because zero knowledge is not just a misnomer, it's usually an objectively incorrect way to be thinking about what is going on with modern applied cryptography. And most of the time when people do quote-unquote ZK, no part of what they're doing is actually in zero knowledge, which we discussed at length last time. That's why it's cool to see how the terminology has evolved in just the last 2 years. We used to call it ZK because we didn't know what else to call it. Now we call it programmable cryptography, or PC, perhaps because we don't know what else to call it. Now, call me old-fashioned, but when I see PC, I still think personal computer. So I always do a double take when I read a note by Gubsheep or Barry that says something, something PC. But you know what? Hijacking words such as crypto and zero knowledge to mean things that they didn't mean before, it's basically a tradition at this point. So more power to you if PC actually starts to mean programmable cryptography. That might be your most impressive feat yet. So without further ado, I really have to start here. What are we going to be calling this stuff in 2 years, in 2026 or 2027? And I don't mean like literally try to predict the exact words, because if you knew, then we would already be calling things that. But as Gubsheep alluded to in his talk, and some of you already saw, the term programmable cryptography actually predates even the last DevCon. In fact, Gubsheep, Barry, and I discussed programmable cryptography at EdCon a couple of months before the last DevCon. But we didn't discuss it in the way that we are talking about it now. It was more vibes and intuition than realization and understanding. So really, for any of you, what jumps to mind for what might be the vibes and intuition of how we are going to be talking about and thinking about this in a couple of years? Anyone?
I think we're going to slowly stop talking about zero knowledge proofs and snarks and starks, and we'll just start using the word proof. And like lots of mathematicians are going to get upset, but like that's like fine, right? Because like we made the economists upset by just like abusing the hell out of the word inflation, so let's just do it to mathematicians too. So, yay, we'll prove Ethereum blocks.
I think that the advent of things like FHE and IO is going to mean that the way that people think about programmable cryptography will be based upon those technologies more than zero-knowledge proofs. So I think that we will have things like faith and destiny become the kind of primary vibes that people interface with this.
I think I remember in one of our last conversations that was particularly centered around zero knowledge, we discussed how the idea of what people were calling ZK apps at the time might not be a complete outlook actually on what is possible with this technology. You know, the point of these applications was not the fact that they used zero knowledge, but it was the fact that they actually did something. They brought some new kind of capability that wasn't possible before, whether that's a privacy capability or a verifiability capability or something like that. And I think that, you know, to use a historical example, this is sort of like when we talked about websites as .coms, right? There was some point in time where we talked about the idea of like, oh, this is a .com company, and well, look how that turned out. Eventually, we started moving to things like, oh, here's a browser-based game, or here's like an e-commerce storefront or something like that. And, you know, similarly, we don't call things HTML apps or HTTP apps. We've started to move away from that in the ZK world. I hear ZK apps less and less these days, but I think we're going to also face the same kind of problem with programmable cryptography and cryptography apps. There's not really applications of programmable cryptography. It's about what you do with them. So I don't know if it's going to be something about like the nature of programs that are collectively run by multiple people, or a capability or a thing that happens as a result, but that's where I would think.
Well, hopefully we'll have more chances to chat about this in a couple of years and beyond, and it'll be really interesting to revisit it, because I think one thing we know for sure is that we won't be talking about these things the same way we are now. So, programmable cryptography and Ethereum, or maybe PC and ETH. I know not everyone here saw the talk that Gubsheep just gave, but real quick, in that talk, Gubsheep did a great job teasing the first topic that I really want to dig in with each of you here on today, which is quite simply, how do we think about PC and ETH together? How do we think about programmable cryptography and Ethereum? And I'll start with an even more direct prompt. Is Ethereum a form of programmable cryptography? And conversely, or maybe complementarily, is programmable cryptography an extension, or is it like a spiritual descendant even of Ethereum? Where does your mind jump to? Vitalik, I'll start with you.
Yeah, I mean, I think it's like a similar type of thing, but different. It's like kind of like how I think about like one-shot signatures, which are this like primitive that Justin Drake loves talking about, but they depend on everyone already having quantum computers. But like the reason why that analogy comes to mind is basically because I think blockchains are not cryptographic algorithms in the way that we think of cryptographic algorithms, but they achieve objectives that are similar to cryptographic objectives, right? Like they give you guarantees that like some data has been published at some point in time. They can create systems that can have a guarantee that like someone who wants to participate can participate, which is a really important property of like voting systems, but like really some of potentially everything. They give guarantees of like verifiability of the whole execution process. One cryptography paper buzzword that blockchains basically do is what they call a bulletin board. So blockchains are, like, I would call them cryptography adjacent because they do similar kinds of things, and in some ways they feel like and work like a cryptography primitive, but they also have enough differences from like things like synarchs and FHE, or proofs and FHE and obfuscation that they're worth thinking about as being their own thing.
One thing I also wonder about is there some root node, perhaps, that both programmable cryptography and Ethereum are specific facets of? Is there maybe some more general way to describe systems or the sorts of programs that we might want to run, where you might say, okay, so this property it's as an implementation detail, something like Ethereum or a programmable blockchain can provide those guarantees. And this other property, as an implementation detail, you can use something like a ZK snark or some form of program obfuscation to achieve that.
Yep. And I think my answer for that is simulated trusted third parties. So this is the idea that you can take a protocol and you first imagine your protocol as running through a trusted third party. So everyone sends everything to Zuck and everyone trusts Zuck and Zuck gives everyone the answers. And then you figure out how to replace Zuck with some kind of construction that has much stronger trust properties, meaning like much less or no need to trust any specific actor. And often parts of Zuck can be replaced by cryptography, but often there are situations where parts of Zuck can be replaced by blockchains.
So it seems to me that they're natural extensions of each other. That Ethereum is an implementation of programmable cryptography ideas, right? That it's just based upon. It's contained within.
One thing that has shaped my thinking is that having programmable cryptography, not necessarily as this entirely distinct thing or an extension, but it seems to be, and this sort of builds on what both Gubsheep and Vitalik were saying, it seems to enable us to, in some situations, think more holistically about what it is we're trying to do, what properties we want something to have, and I mean, 2 is greater than 1, quite literally, and sometimes that additional flexibility, I think, has really helped unlock how we think about things, even when it wasn't maybe strictly technically necessary for that. So I think some of these second-order effects, which are always harder to predict than even the already very interesting, literally what can X versus Y do or not do, is going to be a real big part of the story as we continue to explore. One thing that's also become abundantly clear, at least to me, and I imagine others here would agree, is that programmable cryptography, or at least what we're calling that right now, and Ethereum, I'm pretty sure we're going to keep calling it that at least for a while, those together, the whole is greater than the sum of the parts. These are very complementary, and we're really going to see, I think, a really beautiful synergy, or choose your buzzword here, in the years to come. But for this kind of next section of this conversation, what I'd like to do here is put on this provocateur hat, because if nothing else, it would be entertaining to me and hopefully to some of the folks who are here with us right now. And it's, as moderator, it is my DevCon given right to seek amusement. So I was thinking, what's the best way for me to provoke here? And let's start from the basics. If you want to provoke, you can be reductive and simplistic. So I'm going to be reductive and simplistic, and I'm going to say there's 2 buckets here. There's the programmable cryptography bucket, and there's the Ethereum bucket. So I'm going to start with Vitalik as the, I guess, representative of the Ethereum bucket. Vitalik, what would you like to see the quote-unquote programmable cryptography folks do differently, maybe consider approaching or prioritizing differently, such as potentially placing greater priority on making things that people in the Ethereum ecosystem can use more immediately?
I mean, I think in Ethereum this year we've definitely seen a big shift from just building demos to trying to build applications that really work for regular users and that work at scale. And we've seen plenty of beautiful examples of this, right? So we've seen Farcaster and Polymarket and the usual ones, DDocs, decentralized encrypted Google Docs alternative. We've seen all kinds of different things, and blockchains becoming much cheaper and more performant has definitely been a critical part of that, right? And I think programmable cryptography has been getting to the same transition, right? Where dev tooling around snarks has gotten vastly better and just keeps on improving every year. And I think actually it is time to really have at least some portion of that community approach more problems with, I guess, a product mindset, right? So like one example of this is we've seen this year ZK email, right? And like basically turning email addresses into Ethereum addresses where if you have an email address, you can generate an Ethereum address that can only be controlled by that email address. Like that's powerful. That's like a Web 2, Web 3 integration. That's like a bridge that allows existing like Web 2 users to start using Ethereum applications in this like very direct way that allows you to then just like swap the email address out with anything else later. And I think there's like equivalents of that in ZooPass. There's equivalents of that in the whole other like ZK identity wrapper space. Like basically, really get into that gear of like actually building things that are like next year like everyone here is going to use and like use voluntarily and like not just because the high priests told them that this is like the aligned thing to use.
Gabsheep, I'm curious for your thinking on this, because you're obviously not against the idea of building things that people would find useful. And I also think it's been fascinating to see how Ethereum, not just technologically, but, well, for lack of a better way to describe it, the values and philosophy of Ethereum have been very influential and beneficial to you. So when you hear things like what Vitalik was just saying, what else comes to mind? Like, why is it, I'm going to be, again, reductive deliberately here. Why is it not as simple as figure out the thing that a lot of people can use and go and build that? Or is that what you think you are doing?
Yeah, I think ultimately it has to be, the answer to this sort of thing has to be a yes and I kind of favor an approach that takes at least three things into some kind of balance here. So on the one hand, we absolutely need to be building things that touch real users at the end of the day, that are going for adoption maximization. At the same time, I think that I've seen with myself and projects in the 0x Park orbit also fall into the trap of basically spending a lot of time building one feature, maybe not even one product yet, but one feature. Or you might see when the technology is in really early stages, entire companies, well-funded companies emerge to build one circuit to do one kind of identity transformation or something like that. And I think it's worth taking a step back at times, and we do need to have that kind of feedback loop out in the world, but at the same time balancing that with the approach of, well, okay, how can we always be thinking about how to level up our capabilities and generalize and not lock ourselves in? We've had a lot of experiences where we'll have basically one neat thing that we want to do. Maybe it might be some kind of proof between some sort of identity source and some kind of application that we could imagine using that identity source as authentication. And we might put a couple of engineers who might spend a couple of weeks or even months building the circuit that takes the incoming data schema, converting it, running it through a different proof system and getting some output. And then we might realize after deploying that actually, this is slightly different, or this is maybe even like completely off from what people in the target domain actually want to see from the data in the source. So that's where a lot of my thinking in the last couple of months, maybe a year or two, has started to go around like, well, maybe we don't yet have a complete mental model of what's going on. And before putting all of our eggs into the basket of maximizing for a particular kind of adoption, if we can build systems that allow us to flexibly iterate and experiment, then we can sort of take a balanced approach. And then one thing I'd love to hear from Barry as well is there's at least one more kind of branch that we need to be pursuing simultaneously, which is, well, what if it's not just the mental models about existing technology that aren't there yet, but what if it's the existing technology is completely wrong and something like obfuscation or functional encryption is actually going to solve a bunch of problems that are obstacles for programmable cryptography even reaching any kind of adoption. So some combination of these three approaches in balance is hopefully the way to go. I'd be curious to hear from Barry, though.
So I spent some time thinking about why the first blockchain application was currency. I thought that there was like another world where we could potentially have had a reputation system become the first major thing to use that technology. But I thought about it and I thought that was reasonable for a while, but now I don't think that that's reasonable anymore, because I think that like currency is inherently freer right? Because you can just transfer currency to other people and other people can receive it from you. There's no real barrier to entry. But if you had a reputation system or an identity system, it's harder to transfer reputation. The other major problem is that like currency is able to like interact with the rest of the world very easily, right? Because you can transfer from one thing to another. But like, how do you do reputation and identity systems? How do you use them? Well, it ends up being all about like going to places or being allowed, authenticating to do something. And I feel like this is not a good like business to be in. Like this doesn't seem like a good place to spend our energy because it fundamentally makes systems that are better at excluding people, or it's a more efficient way to exclude people. One thing that like I've looked back on the last year and thought like maybe that was a bad idea was the focus on ZK around ticketing and things like that. Because I feel like making, like there's these arguments that I've heard before that like if you make it easier to KYC people, people will just get KYC'd more. Right? Or maybe KYC is a bad example. If you make it easy to check if someone's over 18 or not, then people will just have to prove they're over 18 if they want to buy eggs or something, right? So like this is my general concern about like going in the direction of like we should just go to production right now. And like this line of thinking has made me feel less excited about building things with zero-knowledge proofs and more excited about building things with more like an interactive technology like FHE and IO and things like that.
So that segues nicely into, I wanted to dial up the provocateuring a bit, and I'll start with Gubsheep. I have one for you as well, Vitalik. For Gubsheep, I guess one lens with how you, 0xPark, and others have been approaching PC, that it could be a bit of, let's call it a skeptical lens, would be that it sort of kicks the can down the road for figuring out the thing, which we certainly all agree is some version of impacting people in a positive way. And I'll even get more specific. One thing that we've discussed is there may even be these kind of correct by construction-ish elements to what's emerging in terms of how this whole programmable cryptography thing works. There's some really interesting stuff there. And actually, if you ask me, I kind of believe that we're going to feel like there's directionally correct by construction things, kind of like how the theory of computation was, or even just like a Turing machine, feels almost correct by construction once you start to really appreciate it, even though it's not obvious at all at first why you should have this tape and these symbols and that should be like the way to think about pretty much all computation, or at least a very remarkably effective way to think about all computation. And yet at the same time, I'd say the Turing machine isn't actually a relevant concept a lot of the time. I would say the vast majority of the time. You know, I've been a professional software engineer. I think it's very interesting, and yet it pretty much never mattered. You could say maybe that's because we got multiple layers of abstraction later or other things. I mean, I think it's somewhere in the middle there. But yeah, that's kind of I want to hear your response to that sort of prodding.
Yeah, so one thing that's been really interesting for me to observe over the past maybe 5 or 6 years that I've been building various things with some of these frontier technologies is this idea that it's been a process of constant generalization. And what generalization gives us is leverage. So to give a couple of examples, this one actually comes from something more adjacent to Ethereum than programmable cryptography. When I started working on Dark Forest in 2019, at the time, the idea of building an on-chain game using zero knowledge seemed kind of like this really interesting or clever trick. We were using ZK in this one very particular way to achieve one very particular kind of interaction on chain. And we built this application using some bespoke patterns because there wasn't any model for this idea of an on-chain game or an autonomous world. And I remember thinking back then, one of our big inspirations for Dark Forest actually was this game called EVE Online, which is one of the oldest and largest MMOs with sort of the most interesting player activity, emergence, longevity, all of these things. And I was just thinking, man, it would be so interesting if someday we could get to a world where EVE Online or something of that kind of complexity was actually running on chain. So I ended up spending about 2 or 3 years building Dark Forest and continuing to just add to the specific Dark Forest circuits, optimizing the specific Dark Forest smart contracts, and adding in all these features. And at some point I met my co-founder at 0xPark, Ludens, who, what he did was he took a look at how we were doing dark forest, and he basically built a mental model for what was really going on. So he kind of built this mental model that was expressed both in software and abstractly, conceptually, for this idea of autonomous worlds and autonomous worlds infrastructure. And they got to work building Lattice and Mud and Redstone and all of these tools. And suddenly it became possible to build not only the next 10 dark forests, but also something like a dark forest that was actually 100 times more complex and interesting, and actually had a shot at getting to hundreds of thousands, millions of users. And actually today it's really interesting. We've closed the loop on this over 5 years, and Eve recently announced that they're going to be building their new game on Ethereum-based technology. So when I think about this sort of question, I think not necessarily like, well, how do we make the perfect abstraction of something like lambda calculus, but how can we build a more general mental model that actually gives us leverage, where in 5 years, because we're thinking about this the right way and we're building the right abstractions, we can actually access those millions of people who might want to use this technology.
That leads nicely to the prodding that I want to throw your way, Vitalik, which my, I guess, straw man counterpoint to the PC should be doing more for Ethereum people today, it would probably be something on the lines of, this is not as generous to Ethereum as I think it should be. But let's just say that Ethereum has made amazing strides, but it still feels a lot like this magical island where the physics works differently. But it only works that way on that island. And there are bigger and better bridges to get over there, but the island is still kind of pretty far, and the bridges are still pretty narrow. It's almost like a bizarro Burning Man, right down to the traffic and just how accessible it is, where it's like accessible, but it's not that accessible. And Ethereum does already clearly have a very big ecosystem, with people doing amazing work on all sorts of fronts. So arguably what Ethereum needs is efforts that kind of aren't just stacking on top of those prodigious existing efforts, but taking this, say, complementary approach, bringing, like a phrase that comes to mind is bringing snippets of Ethereum physics back over to the main continent, to accelerate like how these different worlds can synergize and synthesize. And I'm curious for what jumps to mind when you hear those kinds of thoughts.
Sorry, I'm trying to think of. Can you rephrase the question again?
Yeah, I think what I would boil it down to is, reductively, you could say if programmable cryptography works backward from what Ethereum needs, it may be more marginal in terms of how it can bring what Ethereum really cares about to the world. And that would be one lens that differs at least slightly. I think, again, the real answer is you can do both, but I want to be reductive for the sake of argument.
Yeah, I mean, I think ultimately, it makes perfect sense to have people that are developing the algorithms, and algorithms, I think, are inherently a very general purpose thing. And there are sometimes optimizations that you can make for some use case, but then as we've seen with proofs, right, everyone is just moving to doing proofs over RISC-V, and once you do that, then it's any optimization is basically almost equally valid for any use case, right? And I think for fully homomorphic encryption and obfuscation, a lot of the surrounding primitives, there's a big elements to them which is just general purpose, and it's inherently something where you build infrastructure that either almost any use case or at least very large classes of use cases need, right? And there's one group of people that's very good at and very naturally inclined to do that, and then there's a somewhat different group of people that are more applied applied programmable cryptography in Ethereum people. Sorry, I just realized applied programmability in Ethereum spells ape. It's fine. So you have the applied programmable cryptography in Ethereum people, and then you might realistically end up having several other applied programmable cryptography communities pop up that care about other kinds of problems, and to me that's a natural kind of diffusion. I mean, just there's lots of Ethereum communities that like don't really think much about programmable cryptography, but then even those communities, that's like once the general purpose stuff gets good enough, then they end up using it whether they realize it or not, right? Like anything that's on top of a validity rollup, you know, we're not saying ZK rollup anymore, they're validity rollups, that is a user of programmable cryptography, but they just like don't see it at all. And so I expect we'll see a lot of that.
Well, for the final portion of this talk, which you guys both sort of hinted at, I want to dig into the future, which I'm sure everyone is interested in particular through the lens of obfuscation. But before we do that, and I really only want to take like 2 minutes for this because I do want to make sure we have a chance to explore that topic well, I want to give everyone like 90 seconds to one, get another frog, because I know you guys want to do that. And maybe even scan a neighbor's frog if your neighbor happens to have one. So everyone, feel free to take a moment to actually pull out your phone, search the swamp, and while we're doing that, Gubsheep, I'd love to hear some quick thoughts on what is this whole frog crypto thing about anyway. We saw a glimpse of it at DevConnect in Istanbul last year. Even just like why frogs, but you know, what else is there to it that you might want to say while we have everyone here?
Yeah, so some of you may have noticed the frog hats that have been popping up, kind of like mushrooms, around the conference, or some of you might have swung by the programmable cryptography booth downstairs. Frog crypto came out of being originally a pun on one of the decentralized sort of DevConnect events we ran last year in Istanbul called Prague Crypto, and we sort of realized, I think at some point someone either like typoed it or you know, some part of the P on some signage fell off, and we're like, oh, Frog Crypto, yeah, maybe that could be kind of like a mascot or something. So the idea here is that, you know, these frogs are almost a delivery mechanism for some of the base sort of data of programmable cryptography. This year, what you can do with them is you can collect them on ZooPass. So you can go to ZooPass, press the little frog button, and start collecting a frog every 15 minutes. And what that frog is it's basically an EDDSA signature that's really easy to make ZK proofs about. And various developers have been building games on top of this idea of making ZK proofs about your frogs. One of the new things this year is that you can also scan other people's frogs by holding up your phone and scanning the QR code and sending them a frog request. This allows you to add them as a friend in Frog Social. And what those frog requests those are self-issued attestations to other people who are also participating in this. So what we're essentially doing here is we're building this social graph actually of thousands, or actually I think as of maybe a few hours ago, we might have crossed like 10,000 frog requests that have gone out between different members of the community that we're going to be able to start making all these kinds of social graph proofs on top of. So you can imagine being able to do these reputation proofs. We're already starting to run into a lot of issues with Sybil attacks. So, it just goes to show that cryptography preventing these sorts of social attacks is definitely, there's both like a theory of it, but also a practice to that. But we're excited for this to be a sort of sandbox for people to experiment with the various kinds of functionalities.
Cool. Well, I recently got an obfuscatode, which I was very excited about. And speaking of obfuscatode, let's dig into obfuscation because, and the reason for this is, I can't really articulate this well, but it feels a bit like the quote-unquote next thing. And what I mean by that is, it's a thing that we do understand technically, but I think we're still figuring out how to think about and reason about it in other ways. Kind of like how we technically understood ZK long before we really started to have some of these now seemingly basic conceptual breakthroughs, even like single player versus multiplayer and other things of that sort. There's so many different lenses here. We can look back at the arc of how things have developed and how your past predictions have gone. You can look forward. You can just share new insights and realizations. I'm going to start with you, Barry, because this is something that I know you have been digging into a lot, and you've been one of the primary sources for me to begin to get this sense around obfuscation in the way that I'm describing here.
Yeah, so I'm very excited about the potentials of obfuscation, and it's like part of me, okay, so the way to think about it is that you, like Vitalik was saying earlier, you can imagine that you have this like trusted third party that you can actually trust, and that you can just ask them to do something to help you. And with zero knowledge proofs, they can help you to verify computation, but they can't do anything else. And with MPC, they can do like multiple people's computation, but they're not able to, they have this interaction layer. But with IO, you're able to have this like no interaction required. Basically, you put something in and you get the answer out. And this seems to me that like we're getting so close to what like an actual trusted third party could do that it seems that we might be getting towards the end of cryptography. That like we're at the point where like once we have this, it's hard for me to imagine like what else we could actually have. Because if we could have something else, it would have to be something that like an actual trusted human would not be able to achieve. Like there is a couple of things that IO can't do, like data availability and one-time signature kind of stuff. They can repeatedly, you can force them to do things repeatedly. But like it seems that we're getting to the end of the land. That like, and I don't know what we're gonna do once we get there.
I mean, I think, once if we actually get to the end of the line, which I do think obfuscation in some sense is in a certain sense, because it basically does let you like simulate any trusted third party, with the exception of this, like you can't. That you can't ensure the non-reverting property, and that you can't ensure, well, you can't like do anti-censorship. But like once we get to the end of the line of like base layer technology, then I think that's the beginning of the line for so many more things that get built on top of it, right? And I think this is something that we see in lots of other fields, right? Like there's definitely lots of things that we've seen that have basically approached some kind of optimality, like multiplication. We know how to do it in n-log n now. I mean, and okay, fine, the algorithm that technically does it in n-log n only actually becomes like remotely efficient if you're multiplying like quadrillion digit numbers, but like for everything else we have n-log n, log n, and like do you really care about the difference, right? But then it's like when you have like these fast algorithms that enables lots more stuff in higher level fields to be built on top of it, right? It's like if Fourier or fast Fourier transforms did not exist, then there's an entire class of zero knowledge proof algorithms that would just not be possible, and we would not even be talking about this field in the same way today, right? And then on top of that, then you figure out, once we figure out how to make any trusted third party trustless, and then once we get that down to, there will be a period of like at least a decade where we figure out how to get everything down to the lowest possible level of overhead, right? And then once we get past that, then the question is like, what are all of, like, every time you make an optimization, what are the new things that you can build on top? And then I think even after you're done the optimizations, you can keep on thinking of new things to build on top. Like, I don't think it ends.
Yeah, one thing I think about as well is this idea of, right now, one way we can think about obfuscation is as a drop-in replacement for a trusted third party. And that might enable us to give stronger, security or confidentiality or other kinds of guarantees on top of things that we use trusted third parties for today. But an interesting question for me is, in the spirit of one prompt that we've sometimes discussed is this idea of like, what if obfuscation is not the end, but it's really just the beginning? Like, what is it the beginning of? I suspect that, similar to I have a similar prediction on things like Ethereum and other kinds of cryptography. Once obfuscation or these kinds of technologies become ubiquitous enough, we enter a totally different state of what the internet looks like and feels like. It's not just the internet that we have today, but servers are replaced by these more, trustable or verifiable or confidential services. We actually go from like solid to liquid or liquid to gas in terms of what it even means to be interacting digitally. Now, I don't really know how to think about that. I feel like, I know Barry and Vitalik have some ideas on some of the crazy stuff that might happen there. But that's a prompt that I at least think is interesting to consider.
Yeah, I love that. I'll build on that. It's really hard right now to imagine obfuscation being like virtually free, given that we've barely begun to understand how to even do it, and then the overhead is significant, to say the least. At the same time, you tell someone 100 or definitely 200 years ago that the cost and latency of sending a message, and not just a message, like let's say HD video, halfway around the world, would go to basically zero, I think that would have been even more unfathomable. And so we've seen that these things happen slowly then quickly all the time. And while we've got a lot of heavy lifting, grunt work to do, I do think it's valid to take a moment and say, what jumps to mind as you start to imagine the currently pie in the sky feeling, hey, this is everywhere, this is the beginning, intersections or overlaps with other technologies or other aspects of society. I know this is something you guys have mused about at various points, so curious to hear what jumps to the top of the mind for you here.
So my prediction for the future is that in 20 years there will be like what we would call today a religion that's based upon indistinguishable obfuscation. At the start of the panel I talked about like destiny and faith being the like vibes of the future world, and that's my prediction. I also predict that one member of this panel will become a member of that religion, or that, like, we won't call it a religion, that's a secret. Yeah, like we won't call it a religion in the future, but like today, that's what we would see it as.
Yeah, that's fun. So it's like how Beth Bezos does his thing about thermodynamics, and we get to do our thing about obfuscation. Yeah. Yeah, okay, let's see. Yeah, far future. I mean, well, get into BCIs, and then you get trustless two-way telepathy. Yeah, do you want to like upload your thoughts to Facebook? Probably not, right? But do you want to like have deep communication that involves like sharing thoughts directly with other people? For some specific other people, like sometimes possibly. So that's one of those spaces where like if you don't do it with cryptography, it feels like it's almost default dystopian, but if you do it with cryptography, it feels fine. And like actually having cryptography up to the highest possible standard of usability and just like drop-in replacement power once that stuff becomes available seems like it would be really powerful. Right, like the level you want to get this stuff to, it's like, I think for me the analogy is how our like internet bandwidth is at this point so good. People just like send pictures as a way of saying things that they could have said in like 5 words just because sending the picture is faster. And like to someone in 1980, this would have seemed like batshit insane. Like, no, why the hell are you like voluntarily incurring like 100,000x inefficiency, right? And like these days, of course, we figured out how to cut the inefficiency off of our like lower level bandwidth by a factor of more than 100,000. And so that's like doing that is like actually totally fine, right? And so I think what we want is we want to get the overhead numbers low enough that the question flips from like why programmable cryptography to why not programmable cryptography, and we get more things proven, FHE encrypted, and obfuscated as needed by default.
Yeah, one other thing that I think is a really interesting future to consider as well is this idea that programmable cryptography, or whatever we'll call it in the future, provides an alternative lens on digital agents of the future. So I feel like a lot of the dominant narrative today centers around this idea of, LLMs, we anthropomorphize them, they speak to us in natural language, those are going to be the digital, that's what the digital agent of the future looks like. But there's a very different concept that you get if you take the idea of something like a smart contract, or what we call a cryptomata. You could kind of imagine an obfuscated program running inside of a smart contract with one-shot signatures to its logical conclusion. This might be cryptography's dual to something like AGI would be a cryptomata. And what the cryptomata is rather than this sort of digital god figure that's got its identity that's bearing down on you, it's almost like a force of nature, like a Gaia type thing that pervades digital cyberspace, where wherever I am in digital cyberspace, I can kind of interact with this underlying fabric style thing that just permeates across digital reality. So as one example here, I sort of think of DNS as a very, very primitive version of this kind of digital agent. Wherever I am on the internet, I can reach out to DNS, and it behaves in this very well-structured and useful way that creates some sort of global context. Now imagine taking that capability and ramping it up 100,000 times. Imagine giving that intelligence. That's a very different concept from something like GPT.
So I feel like we're already getting a snippet of this, but we have like a minute and a half left. And so I kind of want to end where we began, but instead of what words we're going to be using in 2 years, what words are we potentially going to be vibing around in 20 or 50? What jumps to mind?
I mean, I think like the words will just become more basic, right? I think it's like, you know, during the like academic like pedant era, obfuscation is called IO, and distinguishability obfuscation, and you put the I lowercase, but then of course that like confuses the hell out of everyone because that's input output. And then I'm expecting we'll just call it obfuscation, and then I expect 10 years after that we'll give up on that too, and people will just talk about encrypted programs. So I think we'll just like start talking about every concept in language that just makes it feel like something much more and more banal and just like something that's a part of life.
Yes, one for me is, as Barry and Vitalik have been saying, if IO gives us all of the powers of a fully trusted third party, then that means that anything further along this trail would have to give us more than what a trusted party or an actual human could do. So there's probably some crazy sci-fi tech out there that goes far beyond what we think of today as cryptography and blockchain, but is a natural descendant. Maybe for the complexity theorists in the room, maybe we'll ascend the polynomial hierarchy or do some crazy stuff with computation. I think quantum is probably like the most immediate thing that's in front of us, but what's after that? I mean, we don't know.
I think that something will happen similar to what happened when we invented money, that we invented all these words like justice and like, so I believe that those will become the like default words that we'll be using in the future. Like honor, justice.
All right, gentlemen, thank you so much for that exciting panel session. Let's give them all a big, big round of applause. Thank you. Now, we're not done yet. We're not done yet. We've got some Q&A coming up, and we're going to show it on the screen. Ladies and gentlemen, let's go. Well, 8 votes for the top question. Two-party MPC could do everything that FHE promises, just much cheaper. Now, in the next 10 plus years and likely ever, are we victims of a VC-powered story takeover? Big question. I'm not sure who wants to answer it, but Albert, I'll pass it over to you.
Yeah, I'll start. If there's a VC-powered story takeover here, that'd be very interesting. I mean, the whole point of that is the money. Where's the money? Are you guys not sharing something here with me? And what's going on?
No, like 2PC is limited to 2 parties though, right? You want to have like multiple parties. So like that's one of the reasons why FHE is more interesting. Like both are interesting. The other big problem with MPC is the interactivity requirement. That's also a problem with FHE, and that's why IO seems to be the most interesting thing for me right now.
Great. All right. Anybody else? If not, we can skip to the next question. That's good. I also want to know where's the VC money in programmable cryptography. Hopefully coming soon. Ladies and gentlemen, next question has, I believe, 7 votes. The second question on the screen. Will the PC allow smart contracts to have signing functionality similar to EOA? Who'd like to take that question? Anyone can. Vitalik?
Yeah, I mean, I guess it depends what you want out of signing functionality, right? Because if you want just like the ability to express authority, then like you don't even need any kind of programmable cryptography, right? You just like use Ethereum's built-in call mechanism already, right? The one thing that obfuscation does that is interesting is that it gives you a snark where the algorithm for verifying the snark just is verifying any kind of signature scheme. And like that comes at the cost of requiring a trusted setup, but that does basically mean that you have like zero-knowledge proofs that are extremely cheap and like that are only as expensive as like just a signature, which is extremely cheap in the current world, and then in the quantum world, like the quantum resistant ones are somewhat more expensive, but it's I think still interesting. Thinking about like the other thing that you could do, like the thing that you definitely kind of can do, but with difficulty, is if you start talking about not signing, but like encrypting and decrypting. Like what if you want a program that has a secret that it releases under smart contract conditions. And the challenge there is like the way that you would do it is you would have an obfuscated program that releases it if it provides a proof of blockchain consensus and that like has like some finalized root, and then the finalized root like shows that some particular condition was met, and then the program only then would actually output the secret. The challenge with this is like basically like one is vulnerability to 51% attacks, right? So if 51% of the stakers come together, they can privately extract the secret without ever like actually being slashed. And one mitigation to this would be to like add a tiny amount of proof of work in, like maybe like 1% proof of work, and then extracting any individual secret would cost like at least a few $1 million. So there's some mitigations there, but like, and so it's like on the bound, it's like possible, but with caveats, which I think is interesting.
Thank you, Vitalik. Possible, but with caveats. Let's go on to the next question. Now, this one's fun. I think Gupsheep just mentioned this very briefly about AI and programmable crypto. The question at the top is, how much autonomy should AI be allowed to have to interact with programmable crypto? Who'd like to take it? Or Gupsheep, can I pass it to you?
Yeah, so one idea that I think is very exciting to revisit from the last 20 years that relates to this question is this idea of the semantic web. So for those who weren't familiar, this was the idea that maybe we could have an internet-wide mega project to take all of the data on the internet and make as much of it possible machine-readable, semantically consistent with other data, make it so that machines can talk to each other in some set of data schemas that are universally interoperable. And I think, you know, the semantic web didn't work out for various reasons at the time. One was the verifiability of data is something that we just, you know, we didn't really have the technology to have programmable verifiability back then. But now that we have programmable cryptography, we can imagine a world where, you know, the current version of autonomous digital agents, which is AIs and LLMs, which are an upgrade over the bots of 20 years ago, can speak in programmable cryptography to each other. So programmable cryptography almost becomes like a language or communication stack for these digital beings of the future. So I'm all for AI being able to interact with programmable cryptography. I think there's like even wilder intersections here, but
one thing I want to add here is programmable cryptography is not like entirely orthogonal to the idea of autonomy, but I think it's more in that direction. Like the question of how much autonomy, what we call AI, because honestly I don't think we know what else to call it right now, that is largely in a different sphere. And what's interesting about programmable cryptography is it's sort of second order, like depending on the autonomy level of AI, programmable cryptography may really shape the implications around it. Like will something decide that it wants a semantic web or those types of things? But yeah, the elephant in the room is like, will AI be very autonomous and will it have, you know, very serious implications? I think that has some maybe interaction with what's going on here. One could say that it certainly has interactions with blockchains. But I just want to highlight that programmable cryptography, at least at a simplistic level, I see as largely like something that's complementary to the autonomy question itself. I'm curious if anyone else wants to chime in on that.
Yes, no, no. All right, he shook his head, so I'll take that as a no. But no worries. Thank you for the answer as well. I think that's quite comprehensive. Autonomous AI, that's going to be quite an interesting future to look forward to. Let's turn our attention to the top voter. I think this is 12 votes, the most I have ever seen so far in any of the sessions. If Ethereum was built with programmable cryptography in mind, rather than Bitcoin with smart contracts, would it have been built differently?
I mean, yes, with like a lot of tiny details, right? It's like if Ethereum was built with statelessness in mind, the gas cost structure would have looked very different. The tree would have looked very different. Lots of things would have been like designed around stateless proving. And for snarks, it's like basically similar. Like gas cost of hashes would have been higher. We probably would have considered just like using Poseidon right from the start, I think. I mean, when I started in Ethereum, I was definitely like in a YOLO-y mood. I probably would have just made Poseidon the hash function. what like there's just a lot of like little tiny decisions that would have been different. I think the core of like being a platform that has accounts and that has transactions and that has a VM probably would have been the same.
All right, thank you very much, Vitaly. Appreciate the insight. We got, I think, 1.5 minutes, so let's try and fit 1 or 2 more questions. Will devs using prog crypto risk punishment like Tornado Cash devs? How to dance with compliance? A bit of a loaded question. Would anyone care to try?
Well, I'm curious what Gubsheep thinks, because this is his problem, not mine. But in all seriousness, I mean, I think that, look, there is precedent. Like, cryptography, in a very simplistic sense, was, you know, there were efforts to try to ban it in the 90s, something we completely forget. Now it's like, you can't not use cryptography to surf the web. Like, no browser will basically let you do that without a lot of pain. And so, I think that the financial aspect of Tornado Cash was obviously a significant part of that. I think that what's fascinating about programmable cryptography is we literally have a precedent that cryptography is everywhere. You all use it every single day, generation 1 cryptography, in the form of like HTTPS and other things like that. So I think there's a very broad surface area. There's always ways to do things in ways that cause these effects. But I think the key thing to keep in mind is that the surface area here is very, very broad, and that's what makes it exciting.
Maybe.
Yep. Maybe it's one quick sentence on it. Yeah.
Yeah, I think that one thing that I think about here is it's about how we really sell the capabilities of the technology. For example, one thing that you can do if you're talking with someone who might be very skeptical is, do you talk about interoperability or do you talk about subverting nation states? And you can talk about interoperability in that conversation. You know, that's sort of what this kind of thing is all about. This is something where we are testing the powerful capabilities of programmable cryptography. You know, it just depends on what foot we put forward first. So.
All right, thank you very much. As the music's playing, that's our cue to say goodbye. Ladies and gentlemen, let's give our speakers another big, big round of applause to all 4 of them for an absolutely fantastic panel session on programmable cryptography. All right. Are we here to work together? Are we here to subvert nation states? Well, only time will tell. Wow. You don't have to leave, you know, ladies and gentlemen. There's going to be another session as well. Let me quickly give you the topic for the next session. The next session is ETH or Ethereum++, a roadmap to real decentralization. Now, there are many things that threaten the decentralization of Ethereum, certain things that are leading to a more centralized blockchain, but our next speaker is going to be sharing about what we can do today, involving a technology called TEEs. Yeah, so if you're interested in that, about how we can decentralize Ethereum, keep it that way, and achieve the original mission, well, stick around. But if you'd like to go to another session, you want to go and visit another talk, no worries. I only ask you for one big favor. If you want to exit right now. Do it as quietly and as quickly as possible. Once again, a big thank you to all of you for asking these amazing questions. We really, really appreciate it. And I must say, it is quite amusing when I see a question come in and then slowly get voted all the way to the top. I feel like I'm running a DAO, you know, just collecting votes every time. But do keep in mind that if you ask any unusual questions, it might get moderated away. I did see some funny questions just now about frogs. Let's try and stay as much as we can focused on the topics as well as the speakers. All right, I still see a lot of movement, and you know, there's a bit of noise while people are moving out. That's fine, I completely understand. We've got over 450 talks across 7 stages, multiple classroom and breakout rooms, so there's lots and lots to see. I often wish I could also split myself into 3 people, one to go eat, one to MC, and one to go and enjoy some talks. But I can't do that, so you've got to make a decision where you want to focus on. I'll just wait another 1 minute for everybody to exit the hall if you're going somewhere else. Yep. Those of you exiting the hall, I've just been informed by the volunteer team, if you could please exit on the left and right, and please enter through the middle. So that will help us a lot with the traffic, right? If you can exit on the left and right sides, and you can enter from the middle of the hall. All right? If you could do me that big favor, that'll be so wonderful. Thank you. All right, the rest of you, if you're sitting at the back, hey, there's some seats that just opened up in front. Why not take your stuff, come closer to the stage. Yeah, it's always great to see a nice full audience right in the front. It really helps the speakers as well, encourages them. All right, if you want to move ahead, go on and move ahead. Now, I also want to remind everybody, you know, when you scan the QR codes and it opens up your Devcon. Hi, you want to take a picture? Hi. Oh, hi, Joe. I didn't see you. Oh, hi, guys. It's nice to see friends all at these conferences. Now, I was saying, as you scan the QR codes and it opens up your Devcon passport and you click on the Q&A, you'll notice there are some extra functionalities there. You can also provide speaker feedback and you can collect cards. Right? You can collect cards for every session that you attend. Now, each session has a unique QR code, so if you want to collect the card, you physically have to attend the session, scan the QR code, and if you see the Q&A screen, you can either ask questions, collect your card, and also provide speaker feedback. Yeah? It's an important part of the process. Even speakers want to hear your feedback so that they can continue to improve their sessions at the next Devcon or any other crypto conference in the near future. All right, I think we're settling down. Those of you who are exiting the hall, if I can ask you, quickly exit the hall as quietly as you can and as swiftly as you can. All right, so that those entering the hall can come in and take their seats and we can enjoy our session together. All right, our next session, ladies and gentlemen, ETH++, a roadmap to real decentralization. Now, the whole mission of the blockchain was to be decentralized. But there are some factors that might be contributing to centralization, things like MEVs, trends in block building. Well, our next speaker is going to be sharing about what we can do and certain interesting technologies known as TEEs, right, that are going to perhaps help us achieve back the mission of decentralization. So please put your hands together and let's welcome our next speaker, Philip, to the stage. Ladies and gentlemen, a big round of applause for Philip.
Hello, Devcon SEA. Vitalik is a very rough act to follow, so thank you for everyone who stayed to talk about decentralization today. So today we are going to talk about deconstructing the nation state, which is how the last kind of panel ended, so that ends up being perfect. And in this talk we're going to cover kind of a bunch of different concepts at a pretty rapid fire pace. So we're going to start with, how does ETH die? How does ETH go to zero? Why are we actually on the road for some possible futures in which this blockchain and this system, which we all love, just like doesn't do as well anymore? How can we save it? What is the formula for that? What does this have to do with ETH3, which I think is a meme you're going to be hearing a lot about in the next few months, few years, etc. What are the technologies we can use? We just heard about programming, privacy, and other things like that. What else can we do? What can you, the attendee here at Devcon and in the space, do to help this? And then what am I doing about all of this, and where do technologies like TEEs come in? So let's get right into it. I'm going to start a little bit funerary today. So I'm going to talk about what I consider to be the two most disturbing pictures in the Ethereum news cycle, the Ethereum space today, at least to me and to my dream of building a decentralized system together with you all. So the first one is from this paper called Regulating Decentralized Systems, Evidence from Sanctions on Tornado Cash, paper published by the New York Federal Reserve, authors listed below. And in this paper, they go fairly deep into analyzing Tornado Cash and sanctions enforcement on decentralized blockchains, kind of enumerating various power dynamics, choke points, and other levers in the system, and then studying how effectively they can kind of manipulate these levers of power to do things like stop technologies they don't like. Technologies which, for example, many people here may have different feelings about. So actually, let me go back to that if I can figure out the clicker. Yeah, so an interesting thing about this picture is it shows the approach that as the nation-state game escalates, as we really go deep into this mission of decentralization, that various kind of centralized parties take on these things we build. And it's very simple. It's about control. It's about the boxes of control. And it's about how to leverage them and make sure we put as many X into these boxes that we see here as possible. So that's the first disturbing picture. The second one, so this is a graphic that you can go browse yourself online. The URL is up there. I can't read it from this distance, but benjdd.com/AWS. There we go. And here you can go through the various different AWS data centers worldwide and kind of view different AWS to AWS latency pictures. In a very real world, this is the topology of the internet, of the networks on which we're building our technologies today. So you can see on the left there, you have US East 1, which is the most popular AWS data center for crypto deployments. And the lighter the color, I guess they changed the color scheme, but I think the blue lines are things that are like approximately on the order of under 400 milliseconds. The light blue line is kind of, or maybe it's under 200, and the light blue line is over 200, et cetera. But you can see there are these very clear corridors of latency and power that we've built. Why is that? Well, because that is where the data centers are. That is where the economic activity is. That is where, in many cases, the users are. That is where companies want to have their servers and want to build their infrastructure. That is where the capital is and the investors and all of these pieces of the puzzle. And so we've built a power overlay using the latency structure of the internet on top of that. And this is what it looks like. So we exist in a world where there are two fundamental realities. The first one is that much of the world's power is already centralized. That includes military power, economic power, geopolitical power, social power, and more. And on top of that, the disturbing trend is that centralization begets more centralization. So centralization is an accelerationist loop onto itself. This is present in markets through phenomena like economies of scale or winner takes all. It's present in zero-sum games such as trading. It's present in auctions, etc. So when you have one sort of centralizing vector, that tends to bring all sorts of centralization into various aspects of your system, something we really want to avoid if, as we said before, deconstructing the nation state is at all on the radar for this project. So what I would say that given that we are in these situations, we have to stop YOLOing protocol proposals and upgrades in terms of this power dynamic and this topology on which we exist. And instead, we have to start treating distribution of power globally as a first-class goal for the next chapter of ETH. How can we be intentional about where we're pushing power in the system? This is much, much more important than the performance of the system. Fast block times, throughput, latency, anything like that. Because if you have those things without having distributed power, you've essentially just reinvented the systems that we were trying to escape this whole time. Those performance systems already exist. Otherwise, we come back to the reality where much of the world is centralized and centralization begets centralization. So instead of that, let's stop YOLOing protocol proposals and treat distribution of power globally as a first-class goal in ETH3. Okay, I'm going to exit the infinite loop and instead go to the infinite garden. So this is an actual picture of my grandmother growing her own infinite garden. And I think the solution, the exit to this loop, is planting our own gardens, building our own systems. So let us all together kind of brainstorm this infinite garden of power distribution and think about very intentionally, carefully, and together about where we want power to go. I'm going to give you one troll idea, and I'm sure you're going to hear many more over the next few weeks, but this is going to be ETH3 done my way. This is the best hatching GIF I could find that was free. Shout out Wikimedia Foundation, but it is very cute. All right, so in my opinion, these are the 4 pillars of ETH3 as I see it. And I say pillars because these are actually non-negotiable properties. If either of these 4 things, any of these 4 things are compromised on, we will fail to achieve the goals of cryptocurrency. We will fail to achieve the goals of Ethereum. And as I said in the beginning of the talk, the price will obviously be 0, regardless how much institutional interests or ETFs or et cetera we're able to create. So these 4 pillars as far as I see them, number 1 pillar is permissionless, and I'm going to explain each of these in greater depth. Number 2 is distributed from a technical perspective and a computational perspective. Number 3, and this is the most important property by far, is geo-economically decentralized, and we're going to define that very carefully shortly. And number 4 is neutral builder efficient. So what are these pillars? Let's get into it. Well, the first one is permissionlessness. This is something we should all have at least a little bit of context on in this space. But specifically, I slice it with thinking about MEV and how MEV is expressed in the protocol because that's what I work on. So for me, what permissionlessness means is that any actor is able to express their value or preference into a block at any point in the block construction process. And that value is able to percolate to be expressed through the process and into the system. You might note that this is actually the same as many definitions of censorship resistance. Essentially, if you pay a fee, you get in is one slicing, although there's a lot of kind of details there. Okay, other than permissionless, we must also make ETH3 distributed. So this one is pretty obvious too. This means taking computations that right now require one big computer or one big server and breaking them down into small pieces that we can then distribute kind of all over the network and all over the world. Without doing this, it's hard to imagine how to decentralize. If you require a huge computer to do everything in one central place, that's inherently not decentralized. All right, this property, as I said, is the most important, geoeconomic decentralization. I'll spend a little longer on it. So this specifically is a very specific notion of geoeconomic decentralization, saying that co-location in the protocol must yield minimal additional profit. So this is not saying, hey, we have a node in France and a node in the US. It's not saying, hey, we're on 3 of these AWS topologies of power. We're on 3 of these links, or 5. That is not geoeconomic decentralization. Geoeconomic decentralization is saying that there's a level playing field in your system for people who are participating outside of those existing corridors of power, outside of those existing latency links, outside of that game theory we've created with AWS. And those people must be able to participate as profitably and as meaningfully as the people who are sitting in New York, as the people who are sitting in Japan, co-located with Binance, and etc. If you reduce the participation of those systems in the network, in the iterated game, as time passes, your network collapses to these central points of geography and power, and then you lose any hope at censorship resistance or any of the other properties you want. All right, so those properties sound great. Can we actually build that? Well, this is my troll roadmap to get there. It's a little bit oversimplified, but hopefully it communicates the point. So I believe right now, standing from today, there are 2 things or kind of 2 broad pushes I want to work on. The first is to TEEify everything. Why TEEify? Well, we're going to get more into that in a second. But basically, TEEs allow us to distribute the computation. So remember when we said before, the one big computer becomes many small computers? TEEs give you the trust APIs to make that possible with untrusted parties operating these small computers. And once you have this distribution, you don't have decentralization yet, but at least you're able to start pushing this infrastructure and pushing the power to the edges of your network and outside of those lines of AWS, those lines of power that we have today. So after we TEEify everything, we have to start in a cycle doing 2 things. The first is pushing this power to the edge. As we deconstruct the computation, as we modularize it, we push. And then the second thing is also to reduce the power of actually TEs in our system. So TEs are not a silver bullet. They're not, a magical solution to everything. They give a lot of power in the system to Intel. They take it away from that graph that I showed you earlier with AWS and move the needle a little bit more right now towards Intel and NVIDIA and AMD and other hardware manufacturers. So while I would argue that's better than only having kind of TradFi latency corridors determine the evolution of our network, it's still not perfect, right? And there's a lot we can do using other cryptography, including what we've heard on the panel before, using other alternative TE approaches, open TEEs, things like that, to sort of remove power from the TE itself as well. So I think it's a 2-track approach. Once we have the platform to distribute and push things to the edges, we then have to actually start pushing things to those edges, and I'm going to cover how you all can help with that shortly, but also start kind of eroding that core power that we've now built up in moving this needle to this other party, which is Intel. So I'm going to ask for your help, please. So please give me your arms, or if you don't have arms, just your body. Give me your soul sounded kind of dystopian, so I'm not going to ask for your soul. But please give me your help in this. And how can you all help with this? Well, if you're a dApp developer, if you're an infrastructure developer, if you're a user, ask yourself, how can we, for our uses, what we're doing, what we're using the protocol for, how can we get power off of these corridors of power that we see here? Can we use endpoints that are in different locations? Do they meet our needs? Can we deploy our server somewhere that geographically makes sense for the change we're trying to create in the world, rather than defaulting to US East 1 on AWS, because it's the first thing that happens when you click launch? Are we able to make that change as a space? I think everyone needs to spend some time thinking about, what am I doing, and is it actually helping centralize power onto these power corridors, or is it actually helping push power out to the edges? Which is what actually underlies the long-term value of decentralization and cooperation, and even the price, yes. Okay, so going back to this graph, Well, one obvious thing you might just say is, oh, we have many boxes. Why not just have many of them just sign, or have some sort of list where the proposer is forced to sign? Well, the reason is very simple, because it doesn't actually solve the power distribution problem. It's not a meaningful solution to censorship in any way, right? If in your metagame you collapse to a state where the system itself is very centralized, no form of technical papier-mâché, technical decentralization, etc., even though it feels really good to us as technologists, it feels great to just say like, hey, we can just do this and it solves the problem. Does it? I mean, let's think about it for a second. So certainly on Binance Smart Chain, it would not. And in general, what I would say is censorship and power dynamics and the way our money works, these are political problems. We're not going to tech tree our way out of these problems. We need to have deeper conversations about where the power is in our network, where we're building power in our network, and how we iterate that towards a place that works better for us. That being said, that doesn't mean that as technologists we can do nothing. Our job is not to make it worse. So please also help me in that if you're participating in this space. Do not centralize power back to those corridors. And remember, today we already live in a world where much of the world's power is centralized, and centralization begets centralization. So I think this is really existential to ETH. We're at the point where we have a choice as a community of, do we start pushing the power we've built outside of AWS, or do we concentrate it, seeking ETF inflows, seeking stock exchange listings, seeking TradFi participation, and concentrate the system to the very corridors of power that we thought we were disrupting. So to get actual decentralization, well, the definition is very simple. It's how much have you pushed this to the edges. And I wish it was something that could be easily quantified, but unfortunately it's not, and that's just something we have to live with. A few more things I have to say. So the first is, this is a little bit spicy and a little trolly. I think we should reject the Ethereum endgame. So the Ethereum endgame, for those who know it, specifically is a slightly older, probably like somewhat out-of-date post, so I'm kind of attacking a straw man here. Basically saying that, like, hey, is it really that bad if we have these big centralized machines doing things specifically for MEV, but then we kind of keep them honest with the rest of the network? We keep that lightweight and everything. I think that's defeatism, personally. I think we can decentralize all the things, and I think as long as you have a central corridor of power, a central source of concentrated power, any sort of system on top is not going to be able to meaningfully police or control it. So we need to actually decentralize all the things that require the big machines as well. Doing a deeper dive into how this relates to censorship resistance. So censorship resistance is a very interesting topic. Traditionally in the academic space, it says that if you create a transaction that assume you pay the fees, you'll be included within some number of blocks. That number is called delta. It's called the censorship resistance or synchrony parameter. So one question I have for us as a protocol is, what delta do we actually need, and how do we value various deltas in the protocol against other properties we care about, like power distribution, kind of geographic decentralization, etc. Because as you push delta to 0, you actually get fair ordering out of the censorship resistance definition, right? If you need to be included immediately, as soon as your transaction is sent, well, what does that mean for the person that's on the other side of the world? How does that stack up with them? What if your delta is below the network limit? How does that then get resolved into the protocol? How do we weigh collapsing these trade-offs against other centralizing effects we can create in the MEV space that maybe help us build this robust geopolitical base and actually allow us to push power back into the edges? So I think the most dangerous thing the space can do right now is essentially fetishize and chase one block censorship resistance at the expense of all of the core properties that will actually provide geopolitical robustness and censorship resistance in the long term. I think we haven't had a conversation in the community about how to weigh those two things together. So let's do that, please, before we start YOLOing protocol updates. And let's do that in a way that addresses this approach to censoring our networks. So what we need for decentralization is real global, meaningful distribution of power. That sounds great, Phil. But we all know there's certain things standing in the way of that. So the first one is what I call UX fentanyl. This is a Web 2 mentality that you need to make things faster and more addictive for your users. If your users aren't addicted, if they're not running on your treadmill, if they're not generating returns, you failed. You're a bad person. You're a bad founder. No, that's not the way we build Web 3 applications. I'm sorry. Right? If you chase UX fentanyl, you chase the dragon over and over and over again to the end state, Well, now you need 50 milliseconds. Now you need 10 milliseconds. Now the mind can perceive 5 milliseconds. We've gone down that path in Web 2, and we've ended up with users that can't meaningfully interact with the technology. These zombies that just are kind of fed these inputs, right? How many people like that here? Nobody likes it, right? So let's stop that shit in Web 3, please. Enough. Yeah, seriously. Another one I want to talk about, and this is a little bit mean to the EF, so I feel a little bit bad whenever I talk about this, but napkin research, and I tried to choose a slightly fancier napkin this time instead of like a dirty napkin or something. But I think we do a lot of our research discussions very informally and without even having deep conversations about what are principles, what does censorship resistance mean to us, what does this protocol change mean, how do you define it? I think we can do a lot more. I've written a blog post about a few ideas I have, but I'd love to talk to people because I think the problem with napkin research is when you have a room this big, the napkins become a flood and it becomes too easy to lobby, too easy to capture the process, too easy to get kind of YOLO protocol upgrades and bad ideas shipped into the L1 we all care about. So let's kind of upgrade our napkin. The problem is if you combine napkin research with UX fentanyl, that's a pretty bad situation. So that I think is how ETH goes to zero. It's the combination of napkin research and UX fentanyl eroding the decentralization we've built so carefully and leaving us open to capture, to co-opting, and to rebuilding the systems we sought to evade. So in all of that, the exit must be globally distributed power. There is no alternative. The alternative is $0 ETH. Say it again and again and again, please, in the mirror. Let's move beyond the napkin. This is a table that I have from a talk I gave at ETH Denver. I encourage you to look it up. It talks about all the technologies that we have, including, as we talked about, kind of programmable encryption, and their various trade-offs for deploying in these contexts that we have in distributed protocols, including who would break them, including rent privileges, including geographic decentralization, which I think is the most important row here. We need to jam more about this and fill this table out more. Unfortunately, I don't have time to go deep today, but please check it out and let's discuss more. Okay, I'm going to leave you with one soundbite, why TEEs? Well, they give us the theoretical maximal performance for taking all of these monolithic things we have and distributing them so we can push to the edges. And at least for what I care about, which is the MEV context, we can iterate the security there. And for your dApp, if you want to do this, the recipe is simple. Build demand, distribute the infra to where your demand exists, natively to it, and then scale your network from there. As for what Flashbots is doing, we're doing so many different things in terms of TE-ifying everything, pushing it to the edges, creating platforms for you all to push things to the edges more. There's a lot that's going to be coming out in the next few weeks, so the only thing I can ask is for you to stay tuned or find me later. And please don't forget that I need your arms so that we can get out of this power dystopia. All right, thank you very much, everyone.
All right, Philip. Well. Napkin, fentanyl, and arms. That's quite a fascinating presentation, but nevertheless, let's go right through our Q&A. We've got about 4 minutes left. Is there any value to centralization at all? Or do you believe everything in life should be decentralized? What do you think, Philip?
Yeah, I mean, I think, for example, government is fundamentally centralized, right? And many people find that valuable in many contexts. I think, you know, like, for example, my laptop is like a centralized computing hub for myself. I don't necessarily want to decentralize that. Yep. I think it really depends on the application. I think decentralization is useful where you want cooperation across differences. And that's actually where the power and censorship resistance comes from. The more different people that are cooperating under the same tent, and the more each one walks away feeling like, yes, that was fair, that was a just outcome, the more robustness, the more censorship resistance you get for free. And so I think in those cases, it's not, centralization is harmful, but in other cases, it totally does make sense.
Excellent. Thank you very much. All right, I see people voting and upvoting the questions. Right at the top with 5 votes, TEEs are peak centralization. 3 US companies are local device ZKs a viable alternative. Take it away.
Yeah, so we can have a deeper conversation about ZK. ZKs don't allow for the kind of like interactive group computation that you need to do in a lot of consensus protocols or, for example, MEV or transaction processing. So maybe like kind of at the edges of like, okay, if I show you a proof, maybe you can run this more limited algorithm, yes, but at the core, it's not really the same tech or the same abstraction. I think all of the entries in that table, ZK, MPC, FHE, TEs, etc., crypto economics, they can all chisel away at the centralization. So it's all about using which one is appropriate for your app. Maybe your app is already centralized. Maybe it doesn't need geo decentralization. Then why would you use a TEE, right? Etc. So like, I think it's about putting as much as possible off TEEs and making TEEs also able to be kind of more trusted by having open TEEs and things like that in the future. Right. But yeah, it is a centralization risk for sure.
All right, excellent question, excellent answer. How do you think centralization risk of staking compares to the rest of your pillars?
I'm not sure what centralization risk of staking means, if it means like basically the stake set becoming more centralized or the fact that staking exists centralizing the coin supply. I think there's many like slices of staking and centralization. I think yes, it is kind of implied by the rest of my pillars in my worldview. Like if we have permissionlessness and distribution and specifically geo-decentralization, where it's fair for you to participate no matter where you stake, I think you get less stake centralization. So I would say for me, it's like downstream of the pillars. If you want to slice it there, I think it is a totally valid thing to have on the table. Say like, we don't want centralization into the stake set.
All right, we got 1 minute more. Let's try one last question with 6 upvotes. TEE solve every problem that was previously described in the programmable cryptography session.
Yep.
Why aren't more people promoting them?
Not only do they solve all the problems, but you can use them together to give you defense in depth, to give you various optimizations and things like that. We're building like a lot of stacks to help people do that. So I think a lot of people are promoting them. I think people are afraid. I think people in crypto and in life and in general, they love binaries. Either TEs are broken and they're useless, they're garbage, we need to burn them down, or they're the best thing ever. And like they cast every opinion on TE into one of these 2 buckets. The reality is much more nuanced. They make sense for a lot of applications. They don't for many others. I think people are promoting and using them and seeing success using them actually basically everywhere they make sense. So I do think you will see more people promoting and using them over time.
Definitely in time to come. Ladies and gentlemen, let's give our speaker another big, big round of applause.
Thanks,
everyone. Thank you very much, Philip. Sharing the cutting edge of TEEs for the Ethereum ecosystem. All right, wow. I must say just one thing. If you haven't done it already, just take a quick look around the hall. Look at how crowded it is. Wow. There is not a single seat that's empty, or maybe just 1 or 2. So I've talked to my volunteers, and they've asked for some help. As you can see, there are some people standing at the side, some people sitting on the floor. If there is an empty seat in the middle of any of your rows, can you please fill it in? Fill it in, please, so that people at the side can quickly enter. Right now, we want you to get as intimate and as close to each other as possible, because obviously the next session is very, very popular. Our volunteers are trying to find... Yeah, excellent, thank you. Fill in the seats, fill in the seats. Our volunteers are right here in the middle. They're going to be instructing you to fill in the seats, yeah, because there's so many people. Look at the queue outside. There's barely any space. It's like a Taylor Swift concert. It's full. Yeah, it's full, but we just barely a few seats here and there. Please, again, work with our volunteers. Please listen to their instruction. Now, very important. For those of you outside the hall, I know you can hear me, and I know you really want to come in. But for reasons of safety, we can't let everyone come in because there's always got to be a path where people can walk out in the event of emergency. Unlikely, but we need to have one. There's no seats on the aisle? No sitting in the aisle, all right? Okay, again, our volunteers are going to be directing you guys, so please work with us, work with us. You need to make sure there's at least a clear space in between so that people can walk up and down, all right? We can't have everyone sitting in the aisle and blocking it completely, all right? Now, again, for those of you, if you can't make it into the hall, don't worry. We've got a live stream of the session. Just open up your Devcon passport. Open up your Devcon passport, scroll to the bottom of the session, and you'll see a live stream, together with translation tools as well. It's all through the Devcon app. Now again, try as much as possible, make some space at the side. We need to have a clear walkway on all 3 aisles, okay? We can't block it completely. I wish we could had more people inside, and I know you guys really want to hear the next talk. The next talk is even more special because it says on my notes that the title is redacted. I had to go to Twitter, to our speaker's profile, just to understand what on earth the talk is about. Well, our next speaker has spent months and months researching and trying to figure out what would Ethereum look like if he had to redesign it again, right? So obviously it's a very exciting session. Our next speaker has obviously garnered a lot of attention with his session, even though he has no title. The hall is full. And again, at the back there, I do apologize. I know you guys really want to come in, but please just open your app. You can watch the live stream, or if you want to listen from the back, that's fine as well. For the rest of you here, thank you so much for making space for others as well. Ladies and gentlemen, are you excited for the session? That's what I want to hear. Ladies and gentlemen, put your hands together and let's welcome our speaker, Mr. Justin Drake!
Thank you, and I do apologize for those that are outside. This is a main stage for ants. Next time we'll do better. So the wait is almost over. The thing that I've been working on for almost all of this year is called the beam chain. So the beam chain is a proposed redesign of the consensus layer that incorporates all of the latest and greatest ideas from the research roadmap. And the goal is to try and transition in a safe and fast manner from the beacon chain that we have today to this beam chain, which is much, much closer to the final design of Ethereum. Now, before I share more information, I have two disclosures, disclaimers. Disclaimer number one is that this is just a proposal. This is my proposal, and the proposal will only go forward if there is rough consensus with it going forward. And the second disclaimer is that there is no new token, there is no new network, and we're reusing the same ticker. And Vitalik was very, very clear as to what this ticker is. Now, in the rest of this talk, I want to take what may sound like a totally crazy idea and convince you that actually it's maybe not so crazy, that it might be a reasonable proposal to put on the table to completely redesign the consensus layer. And first, I want to tell you a little bit more about the beam chain and what the big picture vision is all about. So the scope of the beam chain is specifically the consensus layer, and I'm excluding the data layer with the blobs and the execution layer with the EVM. And the reason is that the blobs and the EVM are directly consumed by applications, and there is a need to be forward compatible. And so the opportunity to modify these two layers is rather limited. On the other hand, the consensus layer is not directly consumed by applications, and so there's a big opportunity to shake things up a little bit there. Now, why am I proposing now to do this massive redesign of the consensus layer? And it basically boils down to the fact that the beacon chain is kind of old. The spec was frozen 5 years ago, and in those 5 years, so much has happened. In particular, we have a much better understanding of MEV. 5 years ago, we were extremely naive when it comes to MEV, and since then, we've seen the market really blossom and grow. And we also have a much better understanding of mechanisms that can help us mitigate the negative externalities of MEV. Secondly, from an engineering standpoint, we have this wonderfully powerful technology called SNARKs, where there's been plenty of breakthroughs. In particular, we've seen SNARKs become orders of magnitude faster over the last 5 years, and we've seen the advent of ZK-VMs. ZK-VMs are amazing technology that allows any programmer in the world to make use of this very powerful technology without having to be an expert in cryptography or in SNARKs. And then finally, with the benefit of hindsight, we now know what the mistakes we made with the beacon chain. And we have a bunch of technical debt which is extremely sticky and tends to pile on over time. And maybe now we have an opportunity to clear this technical debt. So I'm suggesting putting the greatest and latest of the consensus layer roadmap in the Beam chain. So I guess it might be worth spending a little bit of time looking at what exactly is in the consensus layer roadmap. There's basically 9 different items, and I've categorized them in 3 different buckets: block production, staking, and cryptography. So the block production has to do with MEV. Right now, we have a lot of centralization at the builder and relay level. And one of the things that we want to do is have inclusion lists that dramatically improve censorship resistance. Once we have censorship resistance with inclusion lists, we'll be in a position where we can cleanly decouple the validators from the block production pipeline. And this is called attester-proposer separation, and there's ideas like execution auctions. And then the final item here in the block production bucket is faster slots. Maybe we can take the 12-second slots that we have right now and shrink them, all while preserving the invariant that if you are on a home internet connection, you can participate as a validator, as a first-class citizen, even if you are in Australia with a high latency internet connection. Second bucket is staking. The researchers, I think, have come to consensus, broadly speaking, that the current issuance curve is kind of broken, and that there is an opportunity to improve the health and long-term outcomes of Ethereum by changing it. The second item in the roadmap here under the staking bucket is this idea of dramatically reducing the total amount of ETH to become a validator, from 32 ETH down to just 1 ETH. And there's ideas like Orbit that have been circulating around recently. And then finally, this is an idea that has happened, that has been talked about for many years, is single slot finality. Can we dramatically accelerate the process of Ethereum gaining finality? And then the final bucket has 2 big ticket items. Number 1, can we snarkify the whole of the consensus layer in real time using reasonable hardware? And then finally, can we make the cryptography that is securing Ethereum sustainable for the next decades and centuries and make it post-quantum secure? Now, the coloring here is meant to suggest whether or not the item in the roadmap can be done easily, incrementally, or whether it can't. So the 4 green items here in the top left corner are items that I think can be done and should be done in incremental forks on the Beacon chain. But then when we get rid of those, we're left with big ticket items, the red items, that I would argue are best done in a more holistic way. So take chain snarkification, for example. In order to achieve real-time proving of the Beacon chain with reasonable hardware, we're going to need to change the hash functions. We're going to need to change the signatures, the way that we serialize and Merkleize the state. And this is a massive change to the Beacon chain. And so maybe there's an opportunity, well, if we were to make such a change, to change other things at the same time. And then a similar thing can be said for the bottom 2 red boxes, faster slots and faster finality. The truth is that 5 years ago, our mindset was security first when we designed the Beacon chain. And performance was not really a main consideration. And with the benefit of hindsight, we found that there are designs that preserve all of the security that we want, and at the same time pick some of the low-hanging fruit that is available to us to improve performance. Okay, so this slide here is trying to show the mapping from the consensus layer roadmap that I showed you and Vitalik's broader roadmap. We have some items that are classified under the merge, some that are under the scourge, and then a couple that are under the verge and the splurge. And the whole point of this slide is to communicate the fact that the Beam chain is not about changing the roadmap, more so than it is about identifying a specific subset of that roadmap and accelerating it and putting a mimetic wrapper around it. Now, one thing that is new in the consensus layer roadmap here is the faster slots. And the reason is that the discussion around faster slots has happened this year in 2024, but Vitalik's roadmap diagram was only last updated in 2023. Now, in addition to being able to potentially accelerate these big-ticket items, there's a lot of technical debt that I mentioned that can be cleared out. If we have single-slot finality, we no longer need epochs. We can just have slots. The deposit contract that we have right now is kind of crazy, and it's a remnant of the merge. And things like the sync committee is infrastructure that we won't need going forward if we have real-time snarkification of the beacon chain. And the list goes on and on and on. And this is an opportunity, as I mentioned, to just clean it up all in one go. And if you're interested in learning more about some of these beacon chain mistakes, last year I did a whole talk where I talked about 20 or so different mistakes that we made in the beacon chain design. Okay, so this is the big picture view of how we have done upgrades to the consensus layer since Genesis. So in the bottom left here, you can see we did Genesis in 2020, and since then, it's been an extremely regular pattern. Every single year, we've had a new fork, and every time we had a fork, we made one incremental change to the consensus layer. So in 2021, we added sync committees. In 2022, we did the merge. In 2023, we added withdrawals. And then proto-dank sharding. And soon, in 2025, we're going to increase the max effective balance. Now, what I expect will happen is that over the coming years, we will continue doing these incremental forks. And we will be picking up the low-hanging fruit that was marked as green bubbles in the roadmap, in the top left corner of the roadmap. But then we're going to kind of hit a wall. And the reason is that once we've picked all of the low-hanging fruit, we'll be left with all of the big-ticket items that are much more difficult to do in an incremental fashion. And this is where the beam fork happened. The beam fork is an opportunity to have a quantum leap forward in terms of upgrading the consensus layer all in one go. And one way to think about the beam fork is as a batching opportunity. We're batching multiple upgrades into one single fork, and this has benefits both technically and from a governance standpoint. And one way to think about this batching opportunity is as ossification accelerationism. This might sound like an oxymoron, but the basic idea is that we want Ethereum to go in maintenance mode as soon as possible. And right now there's this tension because we know that there's these big-ticket items that require a fundamental re-architecturing of Ethereum, and the more we drag it along, the further Ethereum will be in a position where it can comfortably ossify. Okay, part two. I'm going to try and highlight some of the technology that is going into the proposed beam chain. And the way that I would frame this is basically in eras of Ethereum consensus. Initially, we had the proof of work era of Ethereum consensus, and then we moved to proof of stake. And now we're potentially entering this ZK era of Ethereum consensus. And in the ZK era, we would be making heavy use of snarks as a technology. So one place where we'd be making use of snarks is snarkifying the entire beam chain, the entire consensus layer. And this is where the ZK VMs become extremely handy. So imagine that you have implementations of the beam chain in various high-level languages, in Rust, in Go, for example. What you can do is compile these high-level languages down to bytecode that the ZK VMs will understand, and get snarkification without having to worry about the details of the snarkification process. Now, one thing that I do want to highlight is that the only part that needs to be snarkified is what's called the state transition function, which is basically the crystalline core of what it means to be a consensus client. All of the infrastructure surrounding the state transition function, for example, the networking or the syncing or the caching optimizations or the fork choice rule, none of that has to be snarkified. And ultimately, the state transition function is a small subset of what it takes to build a client. And what we've seen recently in the last couple years is RISC-V become the de facto industry standard for these ZK-VMs. So RISC-V is an instruction set, and basically you can take high-level code and compile it down to RISC-V. And we've seen 7 different companies provide these RISC-V ZK-VMs. You may have heard of RISC-0 and SP1, and the list goes on and on. Now, one little side note here is that this exact technology, which is extremely powerful, can also be used at the execution layer for the EVM. But that is a completely different story to the beam chain story. It's one which is extremely exciting because it means that we can dramatically increase the gas limit, as well as vertically scale Ethereum layer 1. But this is going to have to be for a different talk. The other place where we make heavy use of snarks in the beam chain is with aggregatable signatures. We want to have post-quantum aggregatable signatures. And the proposal here is to use hash functions. Hash functions are post-quantum secure, and you can use that as a basic building block to build your cryptography. So we would have hash-based signatures that are produced by the validators, by the attesters, and we would also have hash-based snarks where you can take many, many thousands of signatures and compress them down to just one proof. And with these two combined, you get a hash-based post-quantum aggregatable scheme that could be used for Ethereum. And one little nice detail is that this aggregatable scheme is infinitely recursively aggregatable. So you can take aggregates of aggregates of aggregates, which is something that we can't really do today with BLS. So it's much more flexible. And the reason why I have this proposal here today is because in the last few months, the progress in performance of snarkifying hash functions has gone through the absolute roof. So for those who are in the know, we're now able to prove on a laptop. So this benchmark here was done on a laptop CPU, a MacBook Pro. We're now able to prove 2 million hashes per second, which is an astounding amount of hashes per second. And this means that this hash-based proposal has the potential of being extremely performant for the beam chain. Now, in addition to the very powerful ZK VMs and snarks that we would be using, I also want to highlight that to a large extent, we would also be reusing existing infrastructure. So the networking libraries, libp2p, the serialization libraries, simple serialize, all of that can be reused as is today. Same thing for the PySpec. PySpec is the framework that we use to write the formal specification, the Python specification, and the unit tests, and we can also reuse Protocol Guild, all of which is infrastructure that didn't really exist when we started with the beacon chain. And the same thing can be said about teams. When we started the process of the beacon chain, there was no team, there was no consensus client teams. So the 5 consensus client teams that we have today, this is manpower that can be reused and doesn't have to be rebuilt. And in addition to that, we have dedicated teams that were put in place for the merge, for example, Eve Panda Ops, which does DevOps, and the security team within the Ethereum Foundation. And I also want to give a shout out to the incentives team and to the applied research group, which are also teams that all of this infrastructure didn't exist, and we can just reuse it for free. Okay, final part. So here I want to try and highlight some of the next steps and how I see the future. So one possible outcome here is that starting from 2025, we start the speccing process. So this would be something that a small group of researchers would do, and it would take maybe a whole year. And then in 2026, the building process can happen where clients would start writing production-grade code, and then in 2027 would start an extremely thorough testing process to make sure that this is all production-grade and safe to deploy on mainnet. Now, the next step for me as a researcher would be to start writing the executable spec, which I call the executable roadmap. And the idea is to take the pixels that we have of the roadmap combined with the hundreds of thousands of words that have been written on ETH research and in academic papers, as well as all of the ideas that lie in the minds of researchers, combine all of this and extract the core essence, which would be this executable spec. And ultimately, it would be a very small document, roughly 1,000 lines of Python code. Now, one exciting thing for me here is that the Beam chain, assuming that there is rough consensus to go in this new direction, will be a fantastic onboarding opportunity to bring fresh blood into the space, especially for the consensus clients. So today we have consensus clients in North America, in Europe, in Oceania, and I'm very pleased to be able to announce today that we have already new consensus client teams that are willing to build Beam clients. So we have one which is based in India, which is called the Zeem team. This is a Beam client written in Zig. And then we have Lambda class in South America that has signaled an interest to also write a Beam client. And so if you will also get involved, and we're going to need a lot of excellent talent. We're going to need speccers and networking experts and coordinators and cryptographic experts and client devs. Please reach out at this email address and beam up with us on this new adventure. Thank you so much.
Right, let's hear it one more time. Come on, a bigger round of applause. That was a fantastic presentation. Really, really good. Really appreciate it. And I'm sure the audience appreciated it as well. Now's the time to ask your questions, or if you see an interesting question, please upvote it. Now, for those of you in the hall, don't leave yet, okay? Just give us some time because the volunteers need to clear a bit of the space. There are still a lot of people outside, so at the end of Q&A, don't move. Stay where you are because our volunteers need time to clear the hall later, okay? So just stay where you are and I'll instruct you at the end of Q&A. All right, Justin, let's look at the first question with the 5 votes right on top. Deploying many changes at once is risky in that if any one change gets delayed or has a bug, they all get stuck or roll back. How hard have you tried to break them down in incremental batches?
Okay, great question. So there's many things that I've tried to do to try and de-risk the Beam chain. The first one is to encourage all of the incremental upgrades. Remember the 4 green items in the roadmap that could be done ahead of time. And by going through the process of these incremental upgrades, we're going to go through a lot of the lessons and a lot of the hard work and discover the challenges there and then. The other thing that I'll mention is that the Beam chain is really only about changing the core of the client, which is the state transition function. And a lot of the potential opportunity for bugs, whether it's the networking layer or the Merkleization libraries, or the fork choice rule, a lot of that infrastructure can, to a large extent, be reused. Another thing that I want to do to de-risk the Beam chain is make sure that all of the existing clients are on board. Because ultimately, these are 50 men and women that have many, many years of experience building consensus clients, and they know what a lot of these pitfalls are. And then another thing that I would say in terms of de-risking the Beam chain is that we will have an especially intensive testing period, which could last, for example, a couple years. This is what I had in the Strawman timeline. And during that time, we would do many, many rehearsals on devnets and testnets so that we could grow confidence that there isn't a bug in this big upgrade.
Excellent. Thank you for the answer. Indeed, testing is very essential when it comes to the blockchain and updates. Now, the question that I've seen has gotten the most votes of any of the rooms so far. 20 is the number to beat. Are you okay, Justin, with people calling this Ethereum 3.0? The meme layer of Ethereum wants to do this.
Okay, great question. So in my opinion, the moniker Ethereum 3.0 is not appropriate. And the reason is that the Beam chain is only about the consensus layer. It's not about all of Ethereum layer 1, it's just the consensus layer. It excludes the data layer, danksharding, and it also excludes the EVM. And there's lots of exciting stuff happening at these layers of the stack as well. So this is why I've tried to avoid the Ethereum 3.0 moniker.
All right. I mean, it's a fair answer as well, but people will do what people do best, and they'll call it Ethereum 3.0, and we'll get a few new coins, and people will ask all the exchanges, will my Ethereum change, and all of that. But let's go to the next highest voted question. Which ZK VM will be used for Beam chain, as there's no standardization of ZK VMs?
Okay, fantastic question. So the amazing thing about the proposed design, and actually this is an idea from Vitalik, is that the snarkification would happen off-chain and would not be enshrined in consensus. So what that means is that every independent validator can choose which ZK VM they prefer. So they can use any of the 7 RISC-V ZK VMs, but they can also use non-RISC-V ZK VMs. And ultimately, by having this off-chain snarkification, it means that if there's a bug in one of them, it's very easy to fix. If there is a performance optimization in one of them, you just update your client and you get this performance optimization. And also, it means that we don't have to pick winners and we don't have to add a lot of complexity on-chain. All of this is off-chain complexity at the social layer.
All right, thank you. We got 30 seconds. You want to take the last question at the top? Any way to accelerate that timeline? We moved. Okay. Okay, well, let's take the first. Well, okay, they voted for 18, 19. Okay, let's do that one. Why are ETH researchers obsessed with lowering issuance? It's... Come on, guys. We need the DAO to agree. Consensus. Where is the consensus? Okay, Justin, take whichever question you want.
Okay, I'm happy to answer all of the questions later on outside.
That's fine.
But any way to accelerate that timeline, please email us at beam.chain@ethereum.org if you want to accelerate. Let's go.
All right. Ladies and gentlemen, one more big round of applause for Justin. Absolutely fantastic, fantastic session. Once again, okay, wait, stop. Don't move yet. Okay, let my volunteers clear the back area because it's really crowded outside and we want to avoid a traffic jam. Bangkok already has a lot of traffic. We don't want to put traffic here. So please give my volunteers just 1 to 2 minutes to clear the crowds behind the hall. Don't worry, you'll have enough time to reach your other venues if you want to change. However, I would love for all of you to stay here because we've got another exciting session that's going to be about the history and philosophy of cypherpunk, right? So please stay tuned for that. Now, while you're in the hall, remember to go to your apps, and when you click on the Q&A section in your Devcon passport, remember to claim your card. So if you click on it, you'll see the Q&A session. Before you click Join Q&A, there's a Collect Card. Please collect the cards for each session that you attend, all right? Okay, I can see the crowds have mostly cleared, so slowly and carefully make your way outside the hall. They've opened all 3 doors. Thank you very much. If you could please help us slowly exit the hall. And please make space for others as well. There's lots of us here, but as long as you all make space together, it should be fine. All right? Don't leave anything behind. Ladies and gentlemen, if you're taking your bags with you, just double check, make sure you haven't left anything behind. If you have any bottles of water or bags with you, please take them away as well, yeah? All right, appreciate it. We're going to give just a few moments for the auditorium to clear and reset before we welcome our next speakers. Okay, so if you could help me, if you see the doors open on the left and the right, please exit swiftly and quietly. Thank you so much. We really, really appreciate it. And for those of you staying for the cypherpunk session and privacy session, well, make your way forward, come right to the front of the stage as we learn about the history of cypherpunk, taking down the nation state. Privacy, freedom, these are very important concepts in the world of cryptography, and in the world of the blockchain. And we're going to learn a lot about the history and philosophy. I don't know much about it, so I'm really curious for this session as well, okay? All right, people still exiting the hall, that's absolutely fine. Slowly, slowly make your way outside. On the left and right, you can go out as well. Don't worry, we'll give you guys some time. We'll give you guys some time. You want to make sure everybody goes out smoothly and safely. All right, while waiting, ladies and gentlemen, those of you in the hall, you can go to your Devcon Passport app and you can already start submitting questions. Yeah, you don't have to wait till the session starts. You can start right now. You can go to the app, click on the session, the history and philosophy of cypherpunk, scroll right to the bottom, and then you'll have your live stream, you've got translations, you've got your collaborative notes, and last but not the least, you've got your Q&A. All right, so you can submit your questions already, upvote your questions as well. Okay, those of you at the back, few rows, you can come in front, and come and fill up the front as well. I know the session's about privacy, but let's also practice a little bit of intimacy as we come closer to our speakers. It's always nice, and I can tell you it's a great encouragement to the speakers to see the first few rows filled with people. All right? Okay, ladies and gentlemen, while the audience is still moving out, I know there's so many people, we're going to give them as much time as possible, but we've got to get our show on the road. So if you are exiting the hall, if I could ask you to just be a little bit quiet, just a little bit more quiet so that we can get our session started on the stage. Our next two speakers are going to be talking about the history and philosophy of cypherpunk, you know, how we fight against the nation state, how we want to encourage human freedom through privacy. And so that's a very big topic, a very important topic, and we've got two amazing speakers who are going to be sharing about it together. Please put your hands together and let's welcome Harry and Max, ladies and gentlemen. Come on, you can do better than that. Let's give them a big round of applause as we welcome them to the center of the stage.
Hi, everyone. Okay, so we are here to basically bring back the cypherpunk roots of blockchain technology. I'm Harry, CEO of NIM.
And I'm Max, Senior DevRel for NIM. So also, if you want to talk about building anything with NIM, come find me over the rest of the conference.
So I would just like to begin this talk saying that I'm actually very proud of Vitalik in the blog post where he decided he was not going to bend the knee to Donald Trump just because Donald Trump was going to pump everyone's crypto bags. Donald Trump and authoritarian states are the opposite of cypherpunk. It's the opposite of our ethos. The ethos of cypherpunk is based on meritocracy without borders, right? Not nationalism, not kicking out immigrants, and all sorts of other complete nonsense. So I think it is a good time to kind of go into the history of how cypherpunk came to be. And we're going to do it a little bit differently. I've seen a lot of talks about, Phil Zimmerman and Eric Hughes and the original cypherpunk movement, but there's a lot of stuff left out. So that's what we're going to go through. I'd like to just give a shout out to the father, the inventor of the term anarchism, Pierre Proudhon, who had, at the dawn of the Industrial Revolution, many core concepts that now we are only seeing come to fruition. For example, do you know in 1863, Pierre said, we can replace the monarchy with self-governing communes and collectives and individuals who will coordinate via contracts and create their own popular banking systems. Of course, he was taken out by Marx, and generally kind of no one looks at him academically anymore, but there's really old roots. And then a lot of the questions that we are facing today came forward in what's called the socialist calculation debate, where the question was, how is it that we can reorganize society? Should we use money or not? Should we plan in a centralized way or not? And in most of Austrian economics, Hayek and Van Mises and all these folks came from this debate as a reaction against the socialists from Vienna, like Otto von Neurath, who claimed that money does not capture all the externalities in the well-being of population. So there's a really old history that predates cryptography and the invention of computing about these topics. Should we organize in a decentralized way, returning sovereignty and power to individuals and to smaller communities, or should we centralize power? If you're interested in more, tons of philosophy work here, but the general thesis is that the spread of cryptographic techniques, which were originally the domain of the nation state, because the nation state is based on hierarchies, on the keeping of secrets around agriculture, keeping of secrets on military. Cryptography let this spread into the general population, and this has been perhaps the most defining change in sovereignty since, like, essentially ancient Sumer. Go for it, Max.
All right, so this section of the talk, we're going to go through a couple of, let's say, the more basic, like, technological advances that have happened, and then I'm going to these are things that we imagine that kind of everyone here knows about, but we'll do a quick overview, and then we'll really jump into the more like the social side of cypherpunk and how it feeds back into the technology it creates. So in '67, Whitfield Diffie and Martin Hellman, they kind of introduced public key cryptography into the public domain, right? So it's the idea that you can, for the first time, then you could create a shared secret key with which you could have like secret communication over a non-confidential channel. Beforehand, one of the massive problems of actually like setting up any kind of encrypted comms with people was how do you initially share this secret between both of you, right? This is the public key cryptography, as well as being the basis of like TLS, SSL. It's also obviously like the basis of so much of the crypto that we use today. Can we do the next slide? All right, so then in '79, David Chaum invented mixnets with untraceable electronic mail, return addresses, and digital pseudonyms, right? The TLDR of this is how do you create an anonymous, untraceable communication network that protects the data of your comms, right? As well as the metadata. So can you create something wherein you can't tell who is talking to who and when? Next one.
It's the green.
There we go. And not too long afterwards, he then came out with another concept, which is that of anonymous credentials to defend against a dossier society. So this first line of this paper from 1985, I think sums it up better than a lot of stuff still sums it up today. So computerization is robbing individuals of the ability to monitor and control the ways that information about them is used. So in '85, Chaum was already talking about the lack of agency that people were having with regards to the data that was about themselves and how they communicate in the world, and could already see the kind of possible dystopia on the horizon. So finally, we had Diffie-Hellman. They allowed people to envisage stuff like misnets, which allow you to communicate privately, and then also we have credentials, which allow you to transact privately. These two kind of key cornerstones of like cypherpunk tech that then can be used to envision this kind of better society that we're talking about here. So that was the stuff that I kind of imagined everyone would already know. Now we'll go on to the more fun stuff. So this was Resource One. This was Resource One's project Community Memory. This was the first computerized public bulletin board system. So the first introduction that a lot of people would have had to computing in general. It was in the People's Computing Center in San Francisco, and it was like I said, the first PBS. So the first way that people were able to like freely share and spread information using computer systems. This is interesting because one of the people who is criminally under-talked about in this space was also key in not just Resource One, but also the creation of the People's Computing Center, and that's Jude Milhoon. So, otherwise known as St. Jude, she was actually the originator of the term cypherpunk itself, so the title of this Congress and everything else owes that to her. And as well as being a founding member of the cypherpunks mailing list, she was a civil rights activist, so actually this picture from the Montgomery Police Department is after she got arrested in Montgomery, Alberta on a civil rights march in '67. As well as being a civil, and it was broad civil rights activism throughout her entire life. She was also a senior editor at Mondo 2000, which is now Wired, so you can see how both tech and culture is constantly feedbacking. The feedback cycle is tight, basically. And a couple of choice quotes of hacking as a martial art, a way of defending against politically correct politicians, overly intrusive laws, bigots, and narrow-minded people of all persuasions. These are some of her publications. Take a picture. They're all really fun and good, but we don't have that much time and a lot to get through. So, another piece of culture that fed back into the early cypherpunk movement and became part of it as well is True Names by Werner Winger. This is a novel which actually has the original use of the word nim in terms of pseudonym or hidden name, and was, even though it was written in 81, thoroughly predictive of government surveillance of parallel online spaces. This then fed into one of the kind of like the author of a series of seminal texts within this, right, which is Tim May. So not only just True Names and Crypto Anarchy, which was an essay that then actually Winger enjoyed so much, it was included in the late 90s represses of True Names. He was a founding member of the Cypherpunks mailing list, and his, let's say, predictive power to understand both the potential of this tech, so providing the ability for individuals and groups to communicate and interact with each other in a totally anonymous manner, is something to bring attention to. Finally, a lesser known, let's say, strain of thought that I think is still foundational to a lot of the cypherpunk ethos that we want to like push forward today is that of agorism. So agorism, until fairly recently, when it was like revitalized by the Agorist Journal, so check that out at agorism.xyz. Then this was a kind of, it was a relatively little known strain of political thought, but still had a massive impact on the cypherpunk culture. This is the idea of a counter-economy, right? So possibly a different way of thinking about what we would maybe call parallel societies, or these kind of like non-state, these non-state market structures, right? So his was very much based in anti-statism and kind of went all the way from black markets to grey markets to just unregulated people helping each other out. And the novel that's included here alongside Night is, you could almost think of it as kind of a dramatized thought experiment of a young man who, as society is kind of crumbling down, his kind of journey through the agorist underworld of to regain, I suppose, freedom in the way that Konkin described it. And I'll kick it back to Harry now.
So where things all started getting real for the cypherpunks, it was interesting concepts, and everyone here is inheriting this tradition, was actually, hilariously enough, as the early internet took off, people leaked the secret beliefs of the Church of Scientology, who you may know as a lot of lawyers. And they started trying to go after some of the cypherpunks and crypto-anarchists. And this led to the invention of what was called the cypherpunk anonymous remailer. So you took emails, put them in PGP, sent them to the computer, stripped off the header and sent them out. However, unfortunately, those cypherpunk remailers were attacked. And this led to the first implementation of MixNets called Mixmaster, an anonymous remailer by Lance Cottrell, who I don't know what happened to him. I've heard various rumors, and Lynn Sassaman, who people think could have been Nakamoto. And effectively, you would send your messages through a series of computers and mix them up together. And that kind of unlinked the messages. And this eventually led to Tor by Roger Dingledine, whose talk you should all see, I think, on Thursday. And they basically said, well, you know, MixNets are really slow. Can we build something faster that does web browsing but goes through multiple peer-to-peer relays? And that's the anonymous solution that most of us still use today. And I remember discussing with Roger once. He was like, you know, this hidden services thing, could it be good for? And then, well, it was good for WikiLeaks, right? So WikiLeaks let Chelsea Manning, and folks like Edward Snowden leak documents securely revealing the scope of the mass NSA surveillance and the failure of the Iraq War, so forth and so on. So WikiLeaks is effectively a Tor hidden service. And so it helped change the world in the war in Iraq. And the belief of Julian Assange was by releasing information into the world, people could decide what was true and what's false. And this would slowly eliminate the centralization of power and the conspiracy between the nation states to kind of maintain their domination. Now, the problem is, of course, the nation states weren't very happy with that. They obviously put Assange in jail. I just want to give a shout out to everyone who contributed to Assange DAO. I was good friends with Julian, and I said, Julian, don't you have tons of Bitcoin? He said, I sold it all the dollars. Like, oh, Jesus, what a stupid thing to do. And then he was like kind of unsure about this ETH NFT stuff, but then it raised 16 million, if not more, to help him get out, paid for his legal bills, and it's because of donations from everyone, particularly in Asia, that this happened. So that's absolutely wonderful, and it's a real use case of our technology. After WikiLeaks, there was, of course, the rise of Anonymous, which people may or may not remember from 2011, the first people that supported Arab Spring in Tunisia. Of course, also came together because of Scientology. And some of you may not know this, and he may not be happy that I'm saying it, but Mustafa from Celestia, back in the day, his name was T-Flow, and he was the youngest member of one of the kind of more prominent LulzSec Anonymous crews. And even Vitalik himself was at the kind of before Ethereum took off, he was living with Emir Taki and other people in Spain working on Dark Wallet, the first private kind of Bitcoin wallet, because it slowly occurred to people that Bitcoin wasn't private anonymous and we needed better technology, confidential transactions, so forth and so on. They did what was sort of the first, not ICO, but Bitcoin fundraise, and now Dark Wallet and all the cool stuff before it, like Faircoin and Unsystem, has evolved into Dark Fi. I just want to give Rachel and Amir and everyone here shout outs, and definitely come to Rachel's talk, Lunar Punk Endgame, to know what the future, we're talking about the past, but what the future of cypherpunk holds, and it will be on Wednesday at 4 p.m. on stage 6. And at the same time, as we're seeing this resurgence of the use of cryptography, not to centralize power in the state, but empower individuals through WikiLeaks and so forth and so on, anarchism itself is resurgent. There are now a large amount of interesting and wildly different anarchist books. I'm going to recommend a few here, but effectively they kind of argue that, it's not just, domination is not just a nation state, but domination is how we think of the world itself. That the world is not just something to be manipulated and controlled to satisfy our desires, but the world itself should be autonomous and free. And there's also some newer questions. In this book, I would recommend, there's the Invisible Committee and the Tikkun, a French collective, a book in '99 called the Cybernetic Hypothesis. And in this book, they said capitalism, based on the individual and the nation state, is dying, but actually it's being replaced by something worse. A control society where computers are used to control and manipulate our behaviors and to make us completely transparent to various forms of power and domination, but now the domination is not centralized in the palace, centralized in the king, but spread out and diffused through all society. And so I would just want to kind of end by discussing a little bit. We've covered a lot of history, and hopefully you got some cool screenshots of it, but what is actually the philosophy of cypherpunk? And I think it's actually a descendant of the philosophy of anarchism, which, remember, happened at the same time the nation state itself started forming. And it's just the critique of anarchism, but given technological power through cryptography, which is ultimately a non-violent way to redistribute power relationships away from centralized power into individuals and smaller collectives, whatever they may be, communes, DAOs, so forth and so on. So the decentralization of power is the movement of sovereignty away from the nation state into the individual, and importantly, unlike all the rabid nonsense going on in politics today, it's universal to all humans, that we believe that all humans should have the right to use strong cryptography, the right to transact freely, and to have freedom of speech. And that's like the fundamental, you can see how blockchain technology enables that. And also it's important that we talk a lot about DAOs, but the fundamental structure is more deep. Voluntary association, that via contracts and market structures, we can create a society without domination and exploitation by any form of ruling class or other kind of terrible self-inflicted domination. And then furthermore, that information itself, and this is where cryptography comes in quite useful, should be based on strong anonymity. You should be anonymous, first and foremost. And then you should, as Eric Hughes from the Cypherpunk Manifesto stated, which we kind of skipped over, but it's an excellent small text, I recommend reading it, that the real power of cryptography comes from the ability to selectively disclose yourself to the world. So you don't have a single identity. You can be a different person in different social spaces at different points in your life and amongst different crowds. And cryptography enables that universally using the internet. And this gives us agency over our flows of data, which more and more compose who we are. And the cypherpunk tech is still under development. Again, we have mixed nets. There's quite a few teams working on them. We at NIM are also working on one. Electronic cash, which, of course, you have Zcash and Monero, but decentralized, fast, private eCash is still not a solved problem. And I think this has been incredibly neglected. We need anonymous credentials. We need the ability to selectively disclose. I think ZK Passport and some other teams and Raramo or whatever are working on this. The ability to selectively disclose arbitrary characteristics about ourselves, but generalizable. We're also working on that a bit. And I guess the question we have is, what are the consequences for Ethereum, right? So we have, again, there are two paths of technology, as I think Amir Taki has said, looking at Lewis Mumford. And one path, we have this centralization of mega machinic technology, which sucks power away from the individual into centralized power structures, making us all slaves to the machine. And I think in the worst possible world, blockchain technology would make this worse, that we would be completely enslaved in some sort of libertarian nightmare where our movements and everything we do and our transactions are transparent to everyone and recorded. But the cypherpunk saying is transparency for the powerful, privacy for the weak. So we should have not identities, not soul-bound tokens, not complete nonsense like DIDs, or various authoritarian technology claiming to be self-sovereign, like this self-sovereign identity nonsense, but we should instead support zero-knowledge proofs and anonymous credentials that enable selective disclosure. Okay? Yeah. I really wish people would just not put the word self-sovereign in front of fascist technology and be like, oh, it makes it all better. It's so stupid. Privacy on-chain is not succinctness. Everyone in Ethereum is obsessed with gas fees and making things succinct, but reality is we need private smart contracts, which DarkFi and Aleo and other folks are working on, private transactions, Aztec and Tornado Cash. And again, remember, we have to support our political prisoners. Roman, Storm, Semenov, and Alex, so do support them. And I'll just I'm ending right now, but there's now discussion of adding, someone in the last session said, when should we add privacy to the network in Ethereum? And I would say, what better time than now, and what better people than you all out there? We have mixed nets and MPC solutions, which can help with network privacy and help with inclusion lists to make, Ethereum not a censorship chain, but a real chain open to the whole world. And we need to defend validators from each other to prevent DDoS attacks and clients from malicious RPC nodes. And again, let's not forget another political prisoner who was the only person to support mixed nets when we started, but now is in jail or almost out, Virgil Griffith. So that's it.
Yeah, that's it. Whoa! All right. If everyone had that level of passion, I think we could change the world tomorrow. But nevertheless, thank you for that very passionate speech. And I believe, privacy is an important thing, freedom is an important thing. But let's go over to the Q&A section. And we've got some interesting questions. The top voted question, quite fun. Why does cypherpunk sound so religious? Would a religious fervor lead to cypherpunk being not that different from the future it replaces? Very philosophical question. Some deep ideas there. How would you like to address this?
Well, I would say religions generally start as movements against corruption and centralization.
Wow.
I mean, they do. And then what happens is they're then incorporated into the nation state. So, for example, Buddhism, I apologize, I don't know too much about. But like with Christianity, you have, Jesus throwing the people out the temple, and then all of a sudden merging with the Roman Empire. Right? People do cypherpunk sounds religious because it's fundamentally an ethical and moral movement. And on that level, similar to religion, but rather than promising a pie in the sky, a happy afterlife, we want to create a better society now. And that will lead to passion. I would rather have people be passionate about building a better society now, right now, with the tools we have, than believe in something else.
Well said. You want to add on?
Yeah, if I could just add something as well. I mean, we've also been talking about like anarchy and a lot of anarchist political philosophy as well, which truly, I mean, all of that not solely relies on, but is fully undergirded by the passion of believing in each other as human beings as well. So there's a crossover there with, let's say, like religious fervor, as you said in the question, but I think you can still distinguish those two things in a meaningful enough way, and it's still positive. So,
very much so. Thank you for answering that. Now, funny question at the top. Trump pumping our bags is good for funding cypherpunk's tech research.
Cypherpunk.
Cypherpunk.
I'm just kidding. No, I mean, I would argue, look, more capital has been wasted in the pumping of bags than I've seen before. And there's a double side to the blockchain technology. All the interesting, creative concepts come, at least from my perspective, from the cypherpunk movements. Blockchain, smart contracts, digital cash, anonymous cash. And then you have all this kind of, other stuff coming from more traditional financial institutions, taking financial techniques. And, I'm not against it, letting them be more widely accessible. And I would argue that what you're seeing now is you're seeing the movement, particularly with ETFs and whatnot, is being slowly more and more moving away from cypherpunk ideals and more towards just traditional financial pump and dump scams like whatever Trump is doing with DeFi, World Liberty, blah, blah. And so it's true that some percentage of that money is being spent for cypherpunk tooling, but very little, almost none. Tor project, which has been providing anonymity for decades, their founder is here, Roger Dingledine, but they don't have enough money. Very few people have donated Ethereum. So we have some good uses, like Assange DAO, but most cypherpunk tech is incredibly underfunded. And now because of privacy, blah, 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 and Tornado Cash, people are afraid of touching it and funding it. I know, I raised money from A16 and whatnot. Some people throw down, but it's increasingly hard.
Yeah. Also, just be realistic with what amount of bandwidth you actually have when you're building. If you're optimizing for something to pump a bag, then you will build something that pumps a bag. That is it. So you also need to think about the amount of innovation tokens you have to spend on any of these projects, even though in theory, yeah, you could have your bags pumped by a bad thing happening.
And just quickly, centralized power in general does not empower people. And cypherpunk is about empowering people, so that's why we push for decentralization. Voluntary associations do not necessarily evolve into nation states. Historically, they actually destroy nation states, from barbarians sacking Rome onwards, and I think that's not necessary. And I do recommend that people just basically throw down as much as they can on this tech.
Yeah, this is decentralization.
Thanks,
live
everyone.
on stage, ladies and gentlemen. Fight against the MC and the MC state. Ladies and gentlemen, let's give our two speakers a big, big round of applause for inspiring all of us to fight for freedom. Freedom through decentralization, freedom through privacy. The first speaker to go ahead and answer the Q&A without my cue, so that was wonderful and very funny to watch as well. But nevertheless, that's the kind of passion that we need, right? That's the kind of passion and fervor that we need, not just in one area, but in all areas of our life. You can really transform an entire room, inspire an entire movement built on passion and charisma alone. So that was wonderful to witness. Really, I think one of the most energetic sessions that I got the honor to witness live on stage. Now, ladies and gentlemen, some of you are making your way out. That's fine. Some of you are staying here. That's even better. Now, those of you who are staying, there's lots of places in the front here, on the left and the right. Hey, come forward, and make sure you get up close and personal with our next session. For those of you, the cypherpunk session, please remember to collect your card. What is a card? When you go to your app, your Devcon Passport app, click on the session, click on the Q&A button right at the bottom when you scroll down, and then you'll see Join Q&A, Collect Card. please collect the card. Yeah, it's like a memento of attending the event, right? Kind of like an NFT. So please collect it and make sure you collect all the sessions that you attend. I'll just wait another 30 seconds for people to come in and sit down and settle down. Those of you just making your way in, there's lots of places here in the front, on the right, on the left. We love to see more people coming and enjoying our sessions. And those of you exiting the hall, thank you very much. Please feel free to exit quickly and quietly. Now, the next topic, the title is called The Shape of Protocols to Come. Very nice title. This is going to be the final topic and the final session for the main stage. Okay, so thank you for those of you who stayed all the way till the end. We really appreciate it. Now, Ethereum defies easy categorization. It blends aspects of money, nations, and yet more and more and more. But it doesn't fit neatly into a single category. If you want to know how confusing Ethereum is, just ask the SEC. They have no idea what it is till today. Now, ladies and gentlemen, our next speaker, he's going to be sharing a little bit about this and explaining to us how the shape of the protocol is to come. There's a lot of cutting-edge technology, not just in this room, but all the stages, all the classrooms. We are discussing lots of things on the fringes, on the edge of technology. A lot of things I don't fully understand. Some of you might not. But that's why we're gathered here at Devcon, the biggest Devcon ever, so that you guys can get to enjoy and listen to these speakers. Now, I want to remind you that you can already start submitting your questions for this topic. Yeah, you can already start submitting your questions. Hi, thank you for coming. Please, I'm so happy to see people sitting in the front. Make space for each other. That's wonderful. Please submit your questions in advance and also vote for the questions that you see so that our speakers can choose from the list. All right. Let me just check with the team to make sure our speaker is ready. Is our speaker ready already? Oh, fantastic. She's giving me the okay sign. Ladies and gentlemen, please put your hands together and let's welcome our next speaker, Tim Bako! Let's give him a warm round of applause.
Okay. Oh, nice. Thank you for making it to the real Ethereum 3.0 talk. Hi, I'm Tim Bako. I work at the Ethereum Foundation on core protocol coordination. And as part of this, I spent a lot of time thinking about how we should steward Ethereum. Like, what are the things we need to do or understand to make sure that the protocol evolves in the right direction? And a few years ago, I was quite frustrated because I felt like we didn't even have the right mental models or the right frameworks to think about Ethereum. And the reason for this is, like, Ethereum is quite hard to describe, right? Like, it's this complex thing, and so it leads us to use analogies to describe it. So to use one myself, nice, I have slides. Sweet. To use an analogy myself, I really like the parable of blind man of the elephant to think about this. So when different people look at Ethereum, they'll see something different, right? Some people will look at it, they'll see that there's this asset in the middle, Ether, and think of it as money. Other people will see that, oh, there's like this EVM, it runs computations, it's like this world computer. You can think of it as a settlement layer for everything to use as sort of this global ledger. And even extending that to something like Ethereum's a digital nation state. And all of these things are partially true, but there's ways in which they sort of fall apart if you look at them a bit more closely. Obviously, Ether is valuable. It's like an asset. You can buy and sell it, but it functions very different than, say, fiat currencies. Similarly, computation runs on Ethereum. It's distributed, but the intuitions we have about scaling Ethereum are very different than how you'd approach scaling like a normal computer system. And then when people start talking about Ethereum being a country or anything like that, you know, Ethereum doesn't have a border, doesn't have citizens, doesn't have like natural resources to protect. And so if we don't have actually good mental models to think about Ethereum, we risk sort of misunderstanding what the thing is and sort of doing a poor job of shaping it in the future. So a couple of years ago, I set out to find better ways to go about describing this Ethereum elephant. And one intuition we had around this is that maybe we should zoom out a little bit. And instead of looking into like every part of Ethereum and trying to understand how it works, could we find something a bit broader and effectively find like a higher level class, which in Ethereum would be just a single instance? One inspiration we had for this was the idea of like chaos theory. If you look at chaos theory, you have these abstract formulas that allow you to describe systems ranging from like biological organisms to financial markets. Or another example could be something like economics. People obviously bought and sold things before we had a formal field of economics, but once we had the concepts like, say, supply and demand and how markets work, it allowed us to reason about what was happening in a much clearer way. And so in this case, the framework we landed on was protocols. After some initial discussions, a few of us within the EF and outside had confidence that protocols might be a rich enough topic that if we studied this as a first-class thing, we could derive some general insights that we could then apply back to Ethereum, helping us to guide its stewardship. And so over the past 2 years, we effectively were inspired by this idea of the blind man and the elephant and decided to fund over 50 researchers to study protocols from many different angles and try to give us reports around what they were seeing so that we could see, is there actually a common thing there? We funded people with backgrounds in architecture, law, engineering, environmental management, arts, and way more. And they each sort of spent time collecting these findings. And you can think of this as field notes from touching the elephant in different places. And now I'd like to share some of their findings. You can think of this as a sketch of the shape of protocols. So first off, let's look at how protocols get adopted. Protocols tend to have a pretty slow adoption curve, especially early on. And the reason for this is that they tend to require consensus across many different people in different institutions. So this means that at first you can feel it's almost stagnant, there's not a lot of energy, there's not a lot of process. But then if the conditions are right, you can have very rapid adoptions of protocols. Everyone has this common knowledge about things, and so it can involve very much like a phase shift. And because you have this common knowledge, once you've actually adopted the protocols, it feels it can get very entrenched, actually. So it's like a new status quo in a way. So one way to sort of visualize this is think of it as a reverse Z-curve, where early on you have this initial wiggles of adoptions, and then this sort of phase shift happens where the protocol gets adopted, and then it's a new equilibrium. And the reason for this is just, again, because there's all this common knowledge that's built up across people around why this protocol should be adopted, and they've coordinated on it. So one concrete example here is how time zones got adopted. For decades, there were conversations around time zones as there were more and more trains and railroads across the US, specifically in Europe, but it didn't really go anywhere. Until 1 year, there was actually a conference, which was sort of the tipping point, where at that point in time, people decided, OK, we're going to do time zones. Within a year after that, 85% of the US had time zones adopted. So it sort of went through this phase shift within the span of a year. And now if you think of time zones, it's effectively this protocol we take for granted. And even doing major changes, like trying to change daylight savings time, is this very complicated thing. It's super hard to move from the equilibrium. And one implication of this is that once these protocols get adopted, they'll tend to fade into the background. As researchers were studying protocols, there was this one quote that came up over and over, different domains, that everyone would sort of use as an anchor for how to think about protocols. It's a quote by A.N. Whitehead that reads that civilization advances by extending the number of important operations it can perform without thinking of them. And so we started thinking of protocols as effectively these tools to generate these Whitehead advances, to allow civilization to perform more complex operations by abstracting them in the background. One example of this is GPS. It's this very complex technological protocol that we've deployed across the world, and now we sort of take for granted that you can just position yourself between 2 points in space and not really have to think about it. And to use an example a bit closer to us, you can think of Uniswap as another one, where prior to Uniswap, deploying markets between assets was this long, complicated process, whereas now we have a simple formula that we've protocolized, and you sort of take it for granted that when a new coin appears, there's a liquidity pool that's powered by the Uniswap protocol. And one implication of this is that almost the better a protocol is, the less visible it becomes over time. Think of something like HTTP. You can argue HTTP is the greatest digital protocol that's ever been invented. It powers effectively the entire internet. But when I talk about it, I don't get a strong emotional reaction, similar to how when you use a great product, you notice it, or if you see a beautiful work of art, or you walk into a nice space like the conference venue. HTTP sort of falls flat, and you're yeah, it's a good protocol. But on the other hand, think of bad protocols. One obvious example is air travel protocols. If you're traveling, internationally, and I put these pictures here, you immediately have a gut reaction of what it feels like, right? To take off your shoes, you're scared to be pulled aside, and maybe, this goes well, you fly, but then you're trying to get a taxi to go back to your airport after you're jet lagged, and if the protocol there is bad, you immediately feel it, right? You're standing there outside, it's warm, and there's 100 people waiting for their grabs. And so this was a really valuable insight because it allowed us to sort of, or it sort of illustrated a different lens through which we could start viewing protocols. One of the researchers formalized this and called this the Kafka index, the idea being that it's much easier to reason about a protocol by imagining its worst version across many different dimensions than to try and imagine the best possible version. And again, this is very different than our intuition when, say, building products. If you're building your product, you're trying to think like, okay, how do I build the best version across all these dimensions? You know, I go from like 0 to 10. Protocols are a bit like the opposite. It's more like you have all these dimensions, and you're trying to get from -10 to 0. And when I was thinking about this week, it hit me that this is kind of why the Bitcoin protocol, I think, is so elegant. If you look at the Bitcoin white paper, the second line or so focuses on what is like the core thing it's trying to address. So Satoshi's claim is, you know, trusted third party are like the worst things about online payment system, and the entire protocol is focused on just trying to get around that one thing. If you look at the bottom of the abstract, it sort of says, look, there's all these other parts of the protocol, and they sort of kind of work, but it's sort of less important than the idea that on this one bad dimension, we're trying to optimize to go from -10 to 0. And flowing from this, like if we're trying to like protect these protocols or get them to avoid these bad states, another way that's useful to think about them is to treat them as commons in a way. Commons are these shared resources that have a risk of like being captured or overused. In sort of outside of crypto, people will use this when talking about things like fisheries or pastures, basically natural resources. And obviously in our context, these protocols tend to not have these like physical boundaries. There's things that have clear digital boundaries. You can think of Ethereum itself as having like clear digital artifacts, or even if you consider Linux to be a protocol, you know, it's like a clear thing to point to. But there's also some more diffuse things. For example, think about like the evolution of workplace safety protocols. It's clear that there's like a common good here. You know, there's like this sense of safety and injury and whatnot, but it's distributed across a whole range of institutions without necessarily having like a single artifact. But still, I think it points at an important intuition that, like, if you want to avoid the bad cases, just like for physical commons, we need to have strong stewardship because we want them, you know, we want to protect against capture, overuse, and other risks. And the sort of risk of capture led us to one of the sort of final insights around what's unique about protocols. At the very start of this, we spent a lot of time trying to define what even was a protocol, and especially how it was different than other things. You know, like, what's the difference between a protocol and an API, or a standard, or a grammar? And one thing that became clear through this work is that protocols have a notion of conflict embedded sort of at their core. And you know, you can see this very quickly in something like Ethereum, right? Ethereum is effectively this digital protocol. We have nodes on the network which have to come to consensus about the state of things. So they have all these ways to resolve conflict, you know, by peering or unpeering from each other. There's some more explicit parameters they get to negotiate over, like the block gas limit. But beyond that, we also have these like meta protocols around Ethereum that exist to mediate conflict, like how we plan upgrades. And again, outside of crypto, you could think of something like traffic rules, right? The way that traffic is organized and we're trying to mediate different people going to different places but going through the same roads is another way that like, we have these protocols that manage conflict. And this was like such a central point that it allowed us to sort of simplify our working definition of protocols by about an order of magnitude. So in 2022, when we started this, Danny Ryan had the following definition for a protocol, which I'll have to read, which is a stratum of codified behavior that allows for the construction of emergence of complex coordinated behaviors at adjacent loci. And so this was broadly right, but it was quite verbose. And then through all of this work, at the end of this summer, Venkat, who runs the Summer Protocols program, was able to summarize it in 2 words, which is protocols or engineered arguments. And this is like a really helpful working definition of a protocol, especially when contrasting it with things like standards, APIs, and so on. And so, to recap what we had so far, you effectively have like these 5 initial properties of what the shape of protocols starts to look like. We have this slow adoption and entrenched persistence that we first covered, sort of reverse Z-curve. Then the idea that protocols create these white-hat advances, that they provide sort of this invisible infrastructure that civilization can then build on top of. We have this idea of a Kafka index where you can analyze a protocol by looking through all of the worst versions of it across different dimensions. Then thinking of protocols as commons, which have a risk of being captured and therefore require strong stewardship. And lastly, treating protocols as engineered arguments, so realizing that they embed conflict in many different ways. And this sort of validated the initial thesis, that there was a common thing around protocol that applied across different domains that we could use to discuss our problems within Ethereum and hopefully learn from others as well. And so now I'd like to talk a bit about how protocols may evolve in the future, and specifically how Ethereum may help shape that. And to do this, it's useful to zoom into Ethereum's distinguishing property as a protocol, which I think is hardness. This is a term that Josh Stark coined a couple years ago and defined it as the capability to make the future more certain. Ethereum isn't the only source of hardness in the world, and in this piece, Josh puts out 3 categories. So atoms, institutions, and blockchains. But Ethereum's hardness is special in 3 different ways. First is that it's globally homogeneous, meaning that no matter where you are in the world, you have the same degree of hardness when you use Ethereum. And this is very much not true of atoms and institutions. The second is that it's independently auditable, so anyone that uses Ethereum for hardness is able to verify whether or not a certain thing happened. And then lastly, it's permissionlessly accessible, so you don't need sort of a high barrier to entry to use Ethereum. And so if we use this and understand Ethereum has hardness as its core, we can start to see how it can shape the future of protocols. The first is as a hardened foundation for other things. This is kind of obvious for anyone who's at Devcon here, but it's striking how special and unique this is. There's not many other things in the world that exist to provide sort of this strong source of persistence and reliability to financial assets, cultural artifacts, or even a whole set of protocols built on top of it. So again, it's kind of hard to overstate this, but looking from all these different domains, it feels like something truly unique that we should not take for granted. But stemming from that, there's a more subtle way in which we have sort of hardness at our core, and it's as a hardened culture. And here you can look at hardness both in the way I just defined it, as giving you better certainty about the future, but also in its more traditional sense as battle-tested. Ethereum operates in a pretty adversarial environment, and over time we've developed norms and practices to mitigate and respond to attacks at both the protocol, application, and infrastructure layer. But in parallel to this, we also have a culture of looking really far into the future, of trying to plant seeds for the ecosystem to grow, to become resilient and not dependent on a single institution or set of people, and also have a technical roadmap that's sound in the long term. And so by combining both these hard foundation as a protocol and this softer cultural hardness, Ethereum effectively can impact the future of protocols beyond just crypto. And one way I thought about this is Ethereum is effectively this tool that we can use to harden commons outside of this space as well. And this is because we have this open platform that's very large and sort of very versatile, but that's also fairly sandboxed from the rest of the world. This means we can run experiments that would be probably too risky to happen anywhere else, but that can still happen at sufficient scale on Ethereum and provide value to the rest of the world. 2 examples here on this slide are quadratic voting and prediction markets. Both of these started off as these theoretical ideas that didn't quite have a place to sort of be prototyped in the world. Eventually, Ethereum became that place. We were able to run small experiments and learn from those, improving our understanding, and then leading to much more significant outcomes. Most notably, prediction markets playing a major role in a recent US presidential election. And so I think going through all this and coming back to the original question, I feel like we have a start of an answer to how we can best steward Ethereum. So by understanding, the notes are wrong on this slide, but we'll run with it. By understanding anyways the shape of protocols, we can better calibrate effectively how we approach developing Ethereum in the future. We should expect that things will take time, especially early on, but we shouldn't be too surprised if things gradually happen as a sort of phase shift all at once. We should expect conflict and capture and engineer systems that gracefully handle them. And instead of building for hypothetical utopias, we should be honest about everything and try to solve for failure modes in the protocol. And by having this shared language, this shared framework of protocols, we're able to learn from other communities who otherwise wouldn't be interested in our problems. And at our best, we can also export our best practices out to them. So in other words, understanding the shape of protocols is the way the Ethereum community can leverage its impact beyond crypto. Thank you.
Thank you very much, Tim. Fantastic. You win the record for the first speaker that has finished before time.
Wow.
Every other speaker pushed me to come on stage a bit earlier than expected, but nevertheless, that gives us a little bit more time for some great session of Q&A. I was going through the questions. Some questions are not exactly linked to the topic, so if possible, we want to keep the topic and as our focus. So please ask questions regarding what Tim has shared about protocols, Ethereum, and feel free to upvote as well, right? If you see a question that looks really good, please upvote it so that our speaker can address it. Let's go with the first one on top. How do we converge on a conception of protocols which will be sufficiently specific to lead to useful, actionable
Oh, okay.
it went down.
Second one.
Actionable. Oh, my goodness. They keep. Okay, hold on. I can't scroll down. Can I scroll down? I don't know if the team can scroll down because I was. Yeah. The third one. Okay. Actionable insights while keeping it open. While keeping
Okay, I think I got the question. I'm happy to answer it.
Okay, let's go to number 6. Do you think EF ecosystem operation is a bad protocol because we don't see any feedback channel? That's a good question. Tim, how do you think you'd like to address it?
Yeah, I guess I dispute the premise. I don't think that like there's no feedback channel. I work at the EF and I read all the tweets and I listen to everything. So I think a lot of it is not necessarily visible. You know, the EF doesn't have a suggestion box, but we get a lot of unsolicited feedback, so we don't necessarily need to. And then I think back to what I said earlier, like, and you know, back to Aya's talk this morning, getting the feedback doesn't necessarily mean you have to act on it, right? Like, I think one thing the EF wants to optimize for is leaving the space for others to grow and sort of take ownership about solutions in the space.
Yep.
And so if we just reacted proactively and solved every single thing, others would sort of feel like they don't have the space to do that. But yeah, to the extent to which we have or we don't have good feedback channels, then yeah, that would make it a bad protocol.
That's a good answer, and I want to pick up on that because our previous session with Justin, a very big crowd came in, and he was sharing that if you want to accelerate growth, come and email us and join the team. Don't just watch from the sidelines. You know, giving feedback is good, but participating, I think, even better. Great question, great answer. Let's look at the next one. Okay, what are the takeaways for Ethereum here? Rules of thumb for healthy protocol evolution. Past mistakes we should avoid repeating.
Yeah. One thing that felt good about doing this research is honestly a lot of the instincts of the Ethereum community are pretty good. Like, so it's made me a bit less concerned about this, but you know, like probably the biggest one is like this idea of like solving for the negative versions. And this is maybe not as visible to like people who don't work on the protocol every day. But the main thing that we talk about when we discuss protocol changes for Ethereum is security, right? Like everyone comes in with a new idea for a new feature for Ethereum, and it's always great. It provides a ton of value to user, but there's a security issue with it. And effectively not compromising on Ethereum security is more important in the protocol development process than trying to deliver as much feature or as much value as possible through features. Yep. So that's one of the takeaways where like it's kind of nice that we were already sort of doing it. I do think the adoption bit is something we should think a bit more about, where a lot of the intuitions we have around how Ethereum will get adopted, we probably borrow from like the technology sector and product development, and we should probably be looking more at things like, yeah, how time zones got adopted or how GPS got adopted than products.
Yep, excellent answer. All right, number 4 votes on the top. How does engineered argument differ from logic, defined by Wiki as the study of correct reasoning?
Yeah, I'd say it's like correct is subjective, right? Like, you know, and one of the big things is just this idea that protocols exist to effectively mediate conflict. So everyone thinks their version of the protocol or their view in the protocol is correct, but a good protocol will be able to deal with cases where, yeah, it's incorrect.
All right, thank you. Okay, we're back to our earlier question, which I couldn't finish in time. Hopefully now it'll stay on the board. Don't vote for anything else. Wait, hold on. How do we converge on a conception of protocols which will be sufficiently specific to lead to useful or actionable insights while keeping it open enough to facilitate input of off-chain perspectives?
Wow. How do we converge on it?
You got 30 seconds.
So this is like a low confidence answer, but I think at this point it feels less like there's a single core formula that we can use that will be like perfectly actionable rather than like these many different lenses. So I think one thing that's been useful in this Summer Protocols research is having people from different domains to be able to validate, like, is this an Ethereum thing or is this like a broader phenomena? And yeah, I think just like gut checking against other domains and yeah.
And I think maybe just one more question, the second one on the list, in case anyone's interested. Where was the research published in one place and where was the research published?
Summerprotocols.com, all of the research is there. Yeah, if there's one place to go, that would be it.
Fantastic. And of course, if you want to speak to him later, I'm sure he'll be around for a little bit longer if you want to discuss research. Let's give our speaker, Tim, another big, big round of applause.
Thank you.
Thank you very much, Tim. Appreciate it. All right, ladies and gentlemen, we've come to the end of our session for the main stage. Remember to also claim your card. Yeah, please collect your card for every session that you attend. And we'll be happy to see you again here tomorrow. We're going to be kicking things off in the morning all the way until the evening. Again, we've got so many talks across many stages. Thank you all so much for coming. It's been an absolute pleasure and honor seeing you guys. So excited about each and every session. I really, really appreciate the questions as well. You guys did a great job. For now, we welcome you to exit the hall. Thank you so much. Our team needs to clean up and reset. And we'll see you guys again tomorrow, bright and early. So make sure you don't go out partying too hard at the side events because we got some great content starting early tomorrow morning. Be here at 9:45, all right? Thank you guys so much. I'll see you guys tomorrow.